now. Take it away, Sarah.
Good morning, everyone. My name is Sarah Ryan. I'm the Environmental Director for the Big Valley Band of Homo Indians. I am also co-chair of the California Cyanobacteria Harmful Algal Bloom Network. This meeting today is one of our quarterly meetings. I'll be running it with plenty of help from our other two co-chairs, Dave Karen and also Becky Stanton. We have a full program today, and we are going to the afternoon. We usually try to do that at the end of the year because we are getting annual reports from our regional coordinators as well as the other programs that we have under CCHAB. And so I'd like to welcome everybody. Make sure that you've got your name and organization in the chat, so that will help us take notes better. And we are going to go ahead and move into our first presentation shortly. There has been a change in the agenda. Unfortunately, we won't be having, George Knoecklein from the Northeast Aquatic Research joining us. However, the other person on the agenda, Hillwig Kenyon, will be giving a presentation and including some of his slides. So sorry to hear that George won't be able to join us this morning. So at this point, are there any announcements that anyone would like to make before we move into our first presentation? All right. At the end of the meeting, we will go into the 2022 scheduling. We hope that people will have their calendars out. We'll have a little bit of a discussion of getting our dates down for 2022. I don't know what the state's going to do in terms of when we're going to move into virtual or in-person meetings. Hopefully Becky might be able to speak about that a little bit, or someone from the water boards, but we'll be doing that after lunch. So unless there's any other announcements, I'd like to go ahead and move into our first presentation, which is a combination of updates from the Freshwater Harmful Algal Bloom Program. There is a pre-recorded presentation that we'll go into after that, and then our regional updates, and we'll call each of the regions one by one for the HAB coordinators. So Carly, if you'd like to go ahead and start your presentation, that would be great. And would you like questions during or after?
Let's go ahead and just wait till after the presentation, the pre-recorded presentation, so they have an idea of what we're talking about first.
All right.
And
folks can also put their questions in the chat, and we will try to address all of them if we have time. All right. Thank you, Carly. Go ahead.
All right. Awesome. Thank you, Sarah. So thanks for joining the FHAB program this morning for the first talk. I'm Carly Nilsson, and I am one of the co-leads for the State Water Board's Freshwater and Estuary and Harmful Algal Bloom Program, alongside Marissa Van Dyke, who's also here today. And we commonly call it for short the FHAB program because it's so long. So I'll be starting us off on the FHAB program update discussion on the agenda. And with the new year, we have lots of exciting things that are coming down the pipeline for the program, especially concerning data input, organization, and output. Next slide, please. So first, I'd like to give you an update as to our internal web-based data system modernization project. And secondly, our collaboration with the Commons and Internet of Water in expanding the Water Reporter app for customized California data collection and beyond, because it goes much more beyond that. Next slide, please. So as I just said, we're in the process of updating our FHAB program data system, and we're anticipating it'll go live next month. And it's web-based, and it's much better formatted to collect our HAB data information from our HAB web report forms and incorporate updates from our FHAB coordinators so we can better track and report on HABs throughout the state. So being web-based, it'll give our illness work group partners an opportunity to work in the data system alongside the Water Board's FHAB program staff. And the system will still function similarly to our old database in that it'll continue to populate our HAB portal web map, but it provides quite a bit more functionality on the back end. So looking at this infographic, you can see that information is received in the new data system from the web report form, which is on our on the web page. And then also it's directly from input from the FHAB program staff and partners. So then this information is then validated through the data system and it populates our HAB portal web map as mentioned before. And then this information is transcribed into the weekly HAB update list that's gets sent through the CCHAB network email subscription list. And it's also linked to the portal. So as we look into the future, we envision having information received also from Water Reporter linked to our data system that then will populate our HAB portal web map. And so this will create just yet another method for tribes, community groups, and others to share their data with the Water Board. And the long-term vision is that the information will also directly link with the California Environmental Data Exchange Network so that this data can be readily available for the public. Next slide, please. So now I'd like to go ahead and introduce Water Reporter. Super snazzy. It's a web and more mobile-friendly platform that provides the user with customized data management tools for collection, storage, sharing, visualizing, and exporting of data. So the Commons and Internet of Water have partnered with us to bring Water Reporter app in as a tool to support our engagement with tribes and community groups around data sharing. And most recently, a HAB data module has been developed with feedback from tribes and community groups. And as mentioned before, the module is designed to sync well with the FHAB program's modern data system moving forward. Next slide, please. So with the Water Reporter, each organization can create a unique account and then they can import data via spreadsheet or digital data collection forms. And the system optimizes data management, program collaboration, and sharing of data. The user can include any quantifiable data, including laboratory results, field measurements, and also photos, and then are able to create data visualizations through this tool. So through the Water Reporter app, the user can view uploaded data and add to it, provide data from unexpected observations when they're out in the field, or they can upload data from projects' fixed stations if they're doing like a monitoring program. And the app brings data science and a monitoring network literally to the palm of your hand via your phone or your tablet. And so with that, I'd like to go ahead and turn it over to the detailed pre-recorded presentation, which is by John Dawes, the Executive Director of the Commons. And he's going to go ahead and walk you through the functionality of the app. And there should be some time at the end, hopefully, for some questions and answers. But most importantly, we're just really looking forward to getting this on the ground and getting new user groups to use this app so we can better understand HABs across the state and start better addressing the issue collaboratively.
Hey, Sarah, we're not hearing it, or at least I'm not.
Right, there's no sound coming through.
Organizations across the board. We've actually been a founding member of the Water Data Collaborative Steering Committee, which is also part of the broader Internet of Water effort. And again, our goal at in supporting Water Data Collaborative is really to kind of standardize the approach to data management so that all of these water quality samples and data management around water quality can be leveraged in a number of different ways and really help states and community science groups level up their game on the data management side. So that's sort of a high level of who we are and what we do. And again, our core program and platform that we've been deploying a lot of our services through is Water Reporter. And in a nutshell, so Water Reporter actually started as a very simple data collection system. The early beta of Water Reporter was actually in 2017, where actually a waterkeeper group approached us about building an app that would help volunteers essentially take georeference pictures of specific issues that they'd see in their watershed, because they wanted the small watershed group, or they wanted volunteers as part of the small watershed group to be sort of the eyes and the ears of the river. And so we set out and essentially built a first version of this and found that a lot of different entities really found utility in the Water Reporter platform. And just to give you guys sort of a quick high-level walkthrough of Water Reporter, it essentially started off as this community where we have now about 120 watershed organizations and state governments across the board collecting water quality samples and images on a daily basis. And what's really neat is that each of these observations, like we can search for algae, or really any of these posts or hashtags, they're all geotagged and provide discrete locations and are referenced to the NHD catchment. And so, again, when we first started with Water Reporter, this was really just a very qualitative observational approach to getting community scientists out there. And the system would actually notify a number of organizations that would subscribe to these respective posts. But what ended up happening is that once we were able to really get a good handle on the workflow, we started to see a lot of different use cases emerge with the data. And so in this case, as we created Water Reporter, we noticed there's this really cool interaction that was happening. So essentially, a volunteer would get mobilized and use the mobile application. And once Water Reporter was engaged, that was a great hook to get a lot of community scientists and community monitoring groups involved. And we found that, through having that structured data, they're able to really start to interact closely with either local government or in the case of if we're interfacing with state government, those entities have much more structured data that they can do a variety of different things, and then hopefully get to the point where you have improved water quality and an engaged citizen base there. So that's sort of the really high level theory of change with Water Reporter. So again, without getting too far down into the weeds, which I think I might already have done that, on sort of the qualitative observational side of Water Reporter, these are the main data fields that we're collecting. So latitude and longitude, comments, images, catchment, and then any kind of attributes about the individual user collecting the information. Now, where things start to get really exciting is that as we sort of rounded the bend with just very high level qualitative information related to collecting visual observations of the watershed, a lot of these groups and small watershed organizations that we worked with really needed a way to manage their water quality monitoring samples. So, again, they have a volunteer base that goes out and observes different things. I'm on the East Coast, so like cattle in stream are a serious issue, or you might have effluent coming out of a pipe, or even HABs and those different things. But a lot of these same entities also collected chemical water quality monitoring parameters at fixed monitoring sites. And so it was roughly 2018 when we expanded Water Reporter to actually support quantitative water quality monitoring samples. And so what we're able to do with that is essentially normalize all the different types of data that water quality monitoring groups are collecting, and that's happening through a data source. And I'll get into this a little bit in the live demonstration here coming up, but this is something that I think is a really critical component of our project with your team, and kind of working with Anna, and her and I have been really working hard on sort of figuring out what that data standard and what that schema looks like on the HAB side for all of these different community groups. But essentially, once we sort of standardized that in the context of Water Reporter, what's exciting is that that data type can be proliferated out to a number of groups where they can then participate and they can collect data. It can be data collected of known quality and very easily, tracked and QA/QC'd, and then committed to really any database that you need. And so, again, just to run through this quickly, we collect a specific site ID, and in the case of our quantitative sampling, so these would be data that are collected at a station. We collect all the different geographic information about the station. And then really from there, samples are related to that station, and we can collect any number of samples by a given parameter, date, time, and then any number of fields that come after that. And those can all be essentially related to the station. So this is really a valuable piece, because if we need to accept data from a community monitoring group that has an existing program, or a community monitoring group may need a data management solution, Water Reporter is something that can be very easily integrated. So that's sort of the nuts and bolts of the application in the system. And again, just to cover off on sort of the high points, we provide the ability for groups to manage these data sort of in one web and mobile application, and I'll show you both the data management side. And then the other thing too is that once those data are collected, we provide a number of very easy to configure maps, portable maps and tools that help users just share and merchandise their data. We like to say share and merchandise because we're not really trying to build analytical tools that compete with like Excel and Tableau and all those great systems. We really want the water quality monitoring data that's collected in Water Reporter to be sort of like embeddable widgets that can be shared to other groups to sort of relay information. We do also offer an API, which I'll talk about as well, that makes dissemination and porting data from one place to another really simple. And then lastly, less on the tech side and more on the people side, we do staff full-time support with this product, where myself, Aaron Hoffman, and our devs are made available to essentially field any kind of usability questions, bugs, suggestions, tickets. We do this through a staffed chat line through help.waterreporter.org, and that sort of helps get folks grounded in their use of the system. So I'm gonna just quickly change gears here and give you guys sort of a walkthrough of our data manager utility. So again, all of this, I'm going to actually share an example in the context of one of our existing users, and then I'm going to kind of share where we are on the California HAB side to give you all sort of an example of where we hope to go with this respective work. So just to start off, in the case of Water Reporter, as a user logs in, they're managing all of their data and all of their permissions on user by user and an organization by organization basis. So in the case of my account, it's a little bit crazy because I help manage a lot of organizational pages. So you can see I have a ton of groups that I'm sort of supporting and working with, but in this case, if I was an individual user, I actually have my own, my own place where I can click in and start to manage things. This is very much like, if you had your Gmail account or Dropbox, you'd be able to see essentially all the components that are relevant to you. And then inside this, for the water quality monitoring piece, data that are quantitative are managed in what we call data sources. And so just to give you a lay of the land of our data sources, basically we manage data in a schema, in a format that's agnostic across the board. And essentially what we do is we map the the different data characteristics to exactly the nomenclature that a small watershed organization or an entity that does volunteer monitors follows. So in the case of stations, this is where a user can essentially manage all of the places that they sample. We provide support and functionality for individuals to add images to their stations. They can actually manage the specific location of their station. And then also sort of configure different things like, if there is a limit or a range at that specific monitoring site, where we want to trigger like a threshold or a specific visualization, that can all be contained in the system. And, again, just following the relational data management, parameters are essentially the different types of things that you're measuring for. So in this case, Blue Water Baltimore is monitoring across 19 parameters, and they're able to like enter in their parameter information and also plug in metadata that's associated with how they're collecting that information. And then lastly, samples. So this would essentially be what you're collecting in the field. And so this is all available in the web application, but we also have a mobile app where you can do all of this configuration and collection across the board. And so where it's really useful is in the case of a community that's a community organization that's measuring all of this and undertaking this monitoring effort, they can actually partition different volunteers to be part of this specific data source. So in the case of this one, if we wanted to add specific contributors or volunteers, I set up some examples here just to joke around and share. This is not a volunteer. This is my dog Bug. But you can actually add volunteers to these data sources, and then anytime data is collected into the system, it can actually be QA/QC'd before it hits the database. So this is really like a full end-to-end data management system for water quality monitoring data that's coming in the door. And once that information is all collected, I want to share like the real key pieces here, which is the data are made instantly available through our application programming interface, and users can actually create these really useful visualizations or station maps, which are all portable. So in this case, Blue Water Baltimore has spun up this example where they're actually showing all of their water quality samples across their 49 stations. And what's neat is that they've set thresholds for each of these parameters. So like in the case of like chlorophyll or total phosphorus or total nitrogen, they have specific levels that are set by the Maryland State COMAR regulations. And so anytime they have a sample that exceeds that specific value, the system will actually color that station as like red for above the limit and green for below the limit. And the same logic applies for each one of these samples being scored. So these are rules that can actually be set in the data manager that lets people essentially configure how their data is visualized through these maps. And so where that really sort of unlocks the door for folks is that because these maps are all portable, they can be integrated into third-party websites. So just like, I think a good analog would be like an ArcGIS Online like Story Map or a web mapping application from like Tableau or Esri. It's sort of the same bag of tricks where you can plug sort of this dynamic data map or view into the system and sort of show it any way that you need to. So I'm actually going to pause there because I know I've thrown a lot at you all, and I want to open it up for questions. Right after that, I do want to sort of share some of the future examples and also tie it to this this FHAB work just as examples. But I definitely want to pause and open up the floor for any questions because I know I've said a lot on that front. So any questions? Let's see. And
I don't think
Marissa,
there's anything in the chat yet. Sorry, go ahead.
cool. Yeah, I was just gonna say, I wonder if there's anything in the chat. I was gonna check there, but
Yeah. Anyone has any questions about the functionality? Okay, so we did get a question in from Karen. Does a small group have to pay to use this platform?
Yeah, so it's a great question. So so in this case, like we actually in the case of California, we have support for the next year to cover any group that wants to dive in. Normally, for an organization utilizing it, it's actually a pretty marginal cost. It's $29 a month. But we actually are able for California to do all of this set up for free for groups to jump on through grant funding. So so right now the cost for the year is actually zero on that front.
Thank you. We have a hand raised from Jenna. Go ahead.
Hi, thank you. This is really interesting. So coming from like a monitoring side perspective, and maybe this is a conversation I talk with Marissa or Anna, but I think we know we want this data to come in like as soon as it can. So a lot of monitoring groups have either their field sheets or whether they're paper or electronic.
Yeah.
And so is there a way to, I would hate, at least for me, and like for QA/QC purposes, I hate to re-enter in things twice. So is there a way to like upload a field sheet or something to make it super easy? Yeah, you're shaking your head, so that's good.
Yeah.
I like the whole lap is going to come play here, right?
This is an awesome question. I'm really glad you answered it. And this is actually, this is like where 99% of our work has gone into and continues to go into on the water reporter side. So like all of the data sources that get collected in water reporter and set up here, they do support batch import. So you can do one at a time editing. But what we found a lot is that most of these groups have their own data management system to some degree, whether that's like a pile of Excel sheets or their own Access database or whatever. So what we do is we actually offer an import where essentially a user can create a new import, and based off of how their database is configured in water reporter, so like, you know, they add their parameters, their station IDs, and those different components, the system will actually build out a template for them. So they can essentially download that template, open up the template, and then paste their data in and import it right into the system. So this is, I'm working off of my numbers view, so it looks a little different from Excel, but this is essentially, you know, like my schema that I would drop my data into. So the upload process is really simple. What we're actually working on now is we've gotten a lot of feedback from folks that are actually adopting Google Sheets for managing their data, which I'm sort of on the fence about that as a data management solution. But we are sort of looking at different ways to do dynamic integrations. So like if you have your data up on the web, essentially just dropping a link that either references a sheet or a database, and then our system will go out and grab it and map it to our schema. So that is a component that will be coming, but for now the import works great and allows people to do a number of batch operations. And then again, all of that same functionality works from your phone. So, you know, if you have the mobile app installed on your iPhone or your Android device, you can access and edit all of your data at any time you have an internet connection. So that's something that's all very possible to do. So I hope that answers your question.
Yeah, I have kind of one more follow-up question, if I may. And this is again maybe like relates to like the contract or something like that. So it might be side rail, but at least in the Delta, we have like a parameter which we call a visual indication, where it ranged from 1 to absent to 5 to high for cyanobacteria.
Yeah.
And so I was wondering if that would be easy to add or possible if that is wanted, or I'm just letting you know that that's an option. If you know, water board's interested, I can help.
Yeah. So
integrate that.
yeah, so we actually, I mean, we can support, you know, if that type of a field is something that is, you know, is a drop down. So like, let's say it's something that somebody has to pick from a list. All of those different data types and elements are supported. And I'll defer to Anna a bit on this, because Anna's really helped us develop the data source or the standardized place to put all of our data. But, you know, again, if there's sort of a critical mass of groups that need a specific data type or field, technically it can be added. I think the big question is, like, on the policy side, you know, like what makes sense from a standardization side. So I'm gonna actually defer to Anna, because I don't want to put my foot in my mouth, but I will say that you,
Yeah, of course.
Thanks, Don.
Yeah.
But Anna, you can go ahead.
Yeah. So a couple things. The schema that the data structures that are in Water Recorder for the water board organization match directly with the current schema in our updated database. So there's like a one-to-one match, which when we get to the point where we can pull the data into the database, that'll be easier to do. The groups, the external groups that have their own water boards or water reporter organizations, John, correct me if I'm wrong, but they can like add to whatever they want with their template. So not all of it necessarily needs to be pushed to the water board. And so, you know, if that parameter that you mentioned is important, then they could have that and then visualize that with their water recorder maps and things like that. And another thing I'll add too is the schema that we developed was based heavily on conversations that we had in, what was it, John, 2019? In the before times, with tribal partners and community organizations that already collect a lot of monitoring for FHABs. And so that kind of informed this whole process. And I added a link to the chat. We Marissa and Carly and John and Greg Gearhart and myself and our partners at the Internet of Water are going to be kind of doing a webinar to talk about that process later this week. So if you want to kind of dive deeper on that engagement process and where we're going next, I would recommend tuning into that as well.
And we'll share a link to that webinar that'll be happening later this week. And then for customized stuff and like logistics, Jenna, to get more to your question, we'll talk about it in our second hour, just like the logistics on how we'll actually work at the water boards or with, you know, our FHAB team, which you're part of course. We'll address that a little later.
Yeah. And just to add in, so I'll, you know, as an example here, what Anna was talking about, I think this dovetails nicely into sort of like our work with the water boards, which is that, you know, we're working to figure out essentially the main field standards for all of these different groups across the board. So that work has actually been pretty much like largely completed to date. So what's exciting is that now that we have all the necessary like form field and data management components in place, each of these sort of standard data source containers can be deployed to any community science organization or group that wants to contribute data. And that'll ensure that anytime they mobilize their volunteers or they themselves collect information, it's going to like follow that same data format and schema that's specified by the water boards. And they also have the option, like if they want to create their own sort of set of internal data for data management, like they can do that. But it essentially controls data by types and by by your respective standards in your data source, which is, I think, a really cool thing. So then lastly, just to add some examples here that I wanted to share in terms of what's possible in the future. So as it relates to the work with California water boards, we are actually, in the process, we've actually standardized the specific data source types. And what's really neat about that is that once we have a set of data that are coming into the system, we can actually expose that through a series of JavaScript object notation or JSON application programming interface endpoints. And so what that is, I mean, it's essentially a layer that allows you to split your database from any kind of application development that you want to do. And so where this API is really valuable is if you want to build a web map or say a notification service, or just port data from one database to another format to another database. That's where an API is sort of a critical layer of infrastructure. And so at this stage in the process, what we're doing is we're working with Anna to basically figure out the best way to convert data from our API so that it can very easily be pulled into the specific database for California water boards on that front, so that every time data are approved and collected, that they're very easily integrated into your existing data enterprise. So that's a component that our API layer makes possible. The other stuff, this is just, again, like pie in the sky stuff, but the pieces are all there. So with the API and on the platform side, one of the things that we're working on is essentially the option where if groups want to make their data discoverable in our system, we can actually integrate that with a number of smart devices and AI technologies, such as like Google Home and Amazon Alexa, where, if a user wanted to know details about a specific swimming site or the watershed organization that's collecting the data, these are all components that can essentially be asked and answered with data emanating in the Water Reporter API. Now, again, this is all very selective. We're not like in the business of just like turning this stuff on and seeing what happens. I think the real key piece here is that as we see how folks use this, and there's like, appetite and a desire to go in this direction, we can absolutely support it. But by no means do I want to like make it seem that we just like turn this on and this stuff would happen. But we do have those integration pieces, and we've actually worked through sort of a similar direction on the Blue Water Baltimore side, where we haven't necessarily integrated with a Google Home device on their front, but we have encoded all of their latest station observations into a QR code. And you guys can try this on the screen if you've got your smartphone handy. But what we've done is we've actually integrated our API with a QR code encoding device. So as people collect samples, you can actually plug a specific station card into that QR code. So if you scan that on your phone, what will end up happening is Water Reporter will actually open up the link and the specific URI to where that station lives and give you the latest station results. So I'll refresh my page here. And if you were to scan that code on your smartphone, it should bring you to this specific station location here where you can get the latest result. So, again, just to tie it back to like where we could potentially go is, if we wanted to do like alerts, or post QR codes on local signage with the latest sampling results, et cetera, like that's totally possible to assess swimming conditions. And again, this is from a technical standpoint. The policy piece is a totally different story. But again, the functionality in our API and system is there to be used however folks need to. So So I guess I'll leave it there because I know we're coming up on time. Definitely have to answer another round of questions. And then from there, I'm happy to turn it over to Anna and the rest of the team. But I really appreciate being able to present this to you all today.
All right, that's the end of the pre-recorded presentation. Carly, do you want to get back on to answer some questions?
Yeah, I think Marissa is here too. So yeah, you guys can shoot them our way and we'll try to best answer them the best we can.
Thank you. So people would like to raise their hands if they've got any questions or put something in the chat. Dave or Becky, has there been anything in the chat for?
Not that I've seen.
Okay. Marissa, I guess I have a question. This is Sarah. What about so I see it goes into CEDN, and you know, with tribes, we put our stuff into WQX, the federal database. Have you had any, are there other participants who are doing something similar?
Yeah, good question. So if you, do you mind going back to the slides? I believe it was the third slide that you shared earlier that Carly spoke to. So during the development of the HAB data infrastructure, that module within the water reporter system, many different community groups.
Marissa, hold on just for a moment. Dave, can you pull up that slide that she's talking about? Were you?
Oh,
you
hey Dave,
that?
were you sharing that?
Yeah, I think he was.
No, I wasn't sharing that.
I'm sorry. Okay, so it was Becky. It's the FHAB presentation, and you said page 3.
Yeah, there you go. Thanks, Becky. Yeah. So during the development of the water reporter's HAB module, because you know you can collect all sorts of different water quality parameters in there. They just wanted to have something customized to, you know, concerning algae, concerning bacteria. You can also, you know, collect fecal bacteria data as well. So again, on the lower left-hand side, that's the water reporter kind of like icon. That will feed into the data system at the water boards that populates the map like it does right now for the past 4 years, but you know, we're overhauling our database. And eventually there will be a connection from that database to CEDN. It hasn't been built yet. And again, you know, these components haven't, some of the components here have not gone live yet. And of course, maybe having a little asterisk there for what has not gone live yet would have been helpful. Sorry about that, folks. So the data system, it's supposed to go live in a few weeks in mid-February, and be able to, you know, overhaul the system that populates the map. And eventually there will be a connection to flow with the monitoring data from the water reporter into that data system so that the data can be visualized on the HAB portal map. And we anticipate, you know, once the CEDN database, so that's the California Environmental Data Exchange Network. This is where surface water data is housed for California, particularly from the water boards and other partner entities not receiving water, you know, for permitting, but most every other kind of surface water data is presented there. When that database, it's also been going through reconstruction. When the new data system is going to be called, you know, CEDN 2.0, right? So the next iteration, once that goes live, we'll be able to build a connection from the HAB database there, the central blue icon, to CEDN. So it's a mechanism to get there because, you know, as you stated, tribes are required through the grant process to submit your data to WQX, the federal data system. So, you know, and then the state asks you to put your data also in the CEDN. So working with us through Water Reporter as a monitoring entity, you will be able to eventually get connection to CEDN and meet those needs as well. So you don't have to, you know, export data from Water Reporter and then enter it also into CEDN. This process is meant to, you know, streamline the data entry, data storage, that kind of thing, and data sharing. And while this HAB module was being created, you know, Sarah, your group was an active member providing feedback on what you'd like to see and so forth in that new module in Water Reporter. And several other community groups as well participated. And if you go to Water Reporter app, you can actually see a little bit about what community groups and tribes and other groups have participated and necessarily like seeing their data. So that's a pretty cool interface that we hope to demonstrate in the near term. And we are hoping to also, we are planning on extending free accounts also to county environmental health departments that are monitoring for harmful algal blooms so that they can input their data in Water Reporter and share that with the water boards and get their data populated on the map as well.
Thank you so much, Marissa. If people have questions, we probably should move into the regional reports, but if people have questions, should they contact you or Carly?
Yeah, or the HAB inbox. We'll put the email in there. It's cyanohab.reports@waterboards. We'll put the email. Please contact us there. We're also developing a couple brief fact sheets that give an overview and how you can get connected with us and get free accounts. So that's something that will be distributed on the listserv. And yeah, I'll hand it back to you, Sarah. Please don't hesitate to reach out to us to learn a little bit more, even if you're not ready to sign up.
Thank you so much. All right, we're going to go ahead and move into regional reports, and we're going to start with Region 1. Mike, you are on, and you're running your own slides, so if you want to just pull those up. And we are going to go in order from the regions. So if the Region 2 person can be ready next, that'd be great. Thank you, Mike. Go ahead.
It says host disabled participant screen sharing.
You're in now.
Gotcha. Sorry, 1 second. Are you guys seeing the right screen?
I think if you go under display settings at the top middle, and it'll let you swap, but otherwise it's...
Yeah, the Zoom controls are in the way.
Yeah, we are getting zoomed today on a number of computers here. Could you might be able to just make that larger, might be visible.
Okay, yeah.
We'll
Sorry about that.
just see some extraneous stuff, which is not a big deal.
Okay, is that good?
That is for me.
Looks good.
All right, well, thank you all. My name is Mike Thomas. I'm the FHAB coordinator here in Santa Rosa for Region 1. I'm just going to give you a quick update what happened in our region this season. And to begin, a lot of what we did would not be possible without our partner agencies, and these are at the county, tribal, state, and federal level, and more. So close to here in Santa Rosa, we had a toxic algae alert on the Russian River, August through October 2021. With the help of our partner agencies, we monitored the river. And the reasons for the postings were we had visually abundant benthic cyanobacteria in the river. We also tested some cyanobacterial mats and saw some elevated toxins. And then spat samplers, which I'll show you here in a second, also indicated that toxins were moving through the system. But ultimately, we issued or recommended advisories for 10 locations along the river's length. And just to give you an idea of what we're looking for in the river, here are some benthic cyanobacteria of concern. These include Anabina on the left there, Microcoleus or Formidium in the center, and then Oscillatoria to the right. And it's important to note that sometimes these can look very much like non-harmful green algae. And what we're looking for in terms of visually abundant. Benthic cyanobacteria, as you can see on the left here, are detached mats that have accumulated along a recreational beach. And of course, this becomes an issue for incidental ingestion in pets and small children. And then also on the right there is a spat sampler, which is a resin encased in mesh that is able to desorb and adsorb toxins as they move through the water. So further up north in the Klamath Basin, we are working with several partners, several tribes that are listed here, as well as Pacificor. In the Copco reservoir towards the border, we recommended a danger posting because of elevated microcystins in the water column. Downstream in Iron Gate Reservoir, we recommended a warning because planktonic blooms were visually abundant. And then below those reservoirs in the Klamath River and its tributaries, a caution was issued due to elevated anotoxins in benthic mat samples. And this was through June through October this season. Pre-holiday assessments, I know you all are familiar, coordinating across the state to gather data prior to major holiday weekends. Region 1, 9 water bodies participated in the pre-holiday assessments, and those that resulted in a caution are highlighted in yellow. But these images here show basically as the season progressed, more samples were being collected and more advisories were being recommended. Just listed here, I'll share the slides with you afterwards, are some other things that were going on in the region. Several other cautions that were recommended, educational postings. And then you'll see again here, research in the Klamath Basin, benthic mat sampling resulted in several cautions. Unfortunately, we did have several confirmed illnesses in the region this past season. Dog illnesses, we had 2 confirmed dog deaths in the Trinity area. Human illnesses, we had 3 confirmed illnesses, varying from the South Fork eel, Trinity to Lewiston Lake. And just to give you an idea of some things that are coming up, we have a benthic cyanobacteria monitoring report that will be released in the coming weeks. This is a report on data collected in the eel, South Fork eel, and Russian rivers, 2016 to 19. Basically, it identifies benthic cyanobacteria and cyanotoxins of concern. We compare various sampling and analytical techniques, and then ultimately provide monitoring recommendations on how a benthic HAB program would go about monitoring health risks. And some other next steps, once that report does come out, we will be doing a series of presentations for the FHAB coordinators, to this group as well, and our board. And then we'll be digging into SPAT data, potentially writing a report and testing or launching various projects to determine an optimal deployment length for SPAT samplers. And then the big thing, we'll be reconnecting with all our partners in preparation for the 2022 season. So here's my contact information. If you have any questions, we'll be sharing these slides with you all as well. And I thought this picture kind of sums it up nicely. What we see in the North Coast region is distinguishing between benthic cyanos and harmless green algae in the river. So with that, I'll take any questions or move on to the next report.
Thank you, Mike. While we're loading up Region 2, are there any questions for Mike in the Region 1 report?
Hey, Mike, this is Becky. I would just mention, I know one of the constraints that happened this year was some of the fire access up in that area. And you guys did a great job of keeping us in the loop in terms of where we could follow up and where we couldn't. But I know that was part of the challenge. So I appreciate you guys working through all that.
Yeah, and thank you for your help too, Becky. Definitely.
Mike, this is Dave Karen. I had another quick question. If I heard you and saw the information correctly, you said the dog deaths in Trinity were associated with caution postage or signage. Is that correct?
Yes.
So
Yeah.
only caution, and they still
Yes,
lost dogs.
only caution.
Okay.
We did not recommend a danger, and that is one thing that we hope to discuss internally in the off season.
Yeah, I imagine that's difficult to do where you've got such a heterogeneous distribution of the toxic cyanos.
Right, and then
Yeah.
being able to get out to sample soon enough and timing and all that. Yep.
Right. Thank you.
While we're pulling up the Region 2 slide, there is also a question from Nina Hemphill. Nina, I don't know if this is for Mike or it sounds like it looks like it's for anyone. Has anyone analyzed whether with warming stream temperatures over the last 20 years or the increase in the number of homes along rivers and increased recreation, we might be seeing more toxic algae, or is it a matter of we never monitored before?
I'm not familiar with any reports about that. I did hear that somebody was modeling temperature and potential increases in toxin concentrations, but I'm not aware. I think that would be a good thing to look into.
Okay, thank you. Now we're moving to Region 2, and I believe we have Rebecca doing this presentation.
Yes. Good morning, everyone. If you haven't seen me before, I'm Rebecca Nordenholt, and my colleague Christina Yoshida and I in the fall took over as the FHAB coordinators for the San Francisco region. Carrie Austin is still involved in FHABs a little bit. She's our reservoir expert, so she's still taking the lead on mitigation efforts. And so for the past year, we do the East Bay Parks does very robust monitoring weekly. So we input those reports into the online portal, and I won't go into detail about their monitoring since I'm sure they'll share that with us later. So this map is showing the non-East Bay Park incidents that we responded to. There were only 8. And they sort of ranged from actually being HABs to being, there was a fish kill that was actually due to dissolved oxygen. And there was one place where it was filamentous algae, not actually a HAB. And then there was also one for Linda Lake. It was just, they were following up. They had an issue the previous year, so they were monitoring just in case and didn't have an issue this year. And then there were a few of the remaining places. So Stafford Lake, Marin Civic Center, and Lake Merced did have HAB levels that were concerning. And for the most part, they all have posting signs year round. And in a lot of cases, the areas where we're having issues, there's no water contact anyways. So yeah, we didn't have a ton of response this year. In the future, these are some of the ideas Christina and I are thinking of going forward with. So we have a lot of grazing and dairies, particularly in Marin and Sonoma counties. And we've been in contact with the senior in charge of that program. And she was saying there's really not good outreach about if the stock ponds potentially have HABs. So we were thinking about making some outreach materials to share with them and the local RCDs and things, just to educate them about those issues. And then we don't have a ton of local agencies besides East Bay Parks that are monitoring regularly, or at least reporting it to us. So we're, especially since we're new, we're just wanting to do outreach to get to know everyone and encouraging them to report their monitoring if they're doing any. We wanted to ID more sites for potential holiday sampling in the future. And we're going to be doing a lot of thought towards environmental justice focused projects. And so trying to include HABs into those projects. And so, yeah, that's it, unless there are any questions.
Thank you, Rebecca. Any questions for Rebecca for the Region 2 update or any other Region 2 updates? All right. Thank you. Oh, go ahead, Hal.
Oh, this is Hal. Yeah, I could do an update if you guys want that.
Yes, you have a couple minutes.
All right. Overall, we had like a lower closure days in our lakes. Lake Temescal was down, and Quarry Lakes had fewer closure days. And actually, we had a long swimming time at Quarry Lakes. It was open from mid-June and is still open. Del Val had more closure days and was open to swimming from May to November and is currently experiencing a bad bloom. Anza was closed a lot more than normal. We did test 24 largemouth bass from Del Val, Lake Chabot, Concha Loma, Temescal, and Quarry. Almost all of them had toxins in the livers, and we did detect microresistant toxins in a fillet from Lake Temescal. It was 2.8 nanograms per grams. We did do harvesting PAC 27 and alum tree at Temescal, which kept the cyanos and toxins down, but the nanobubbler was undersized and not working, so we removed the nanobubbler from Temescal. Our hypolimnic oxygenation system at Anza didn't keep our hypolimnium temperatures as low as we wanted. We did not have any fish kills or note any stressed fish, but we really need to work on Anza and how to work that hypolimnic oxygenation system. We did have a couple big blooms in some ponds out. They were doing pond surveys this year. There was a dead cow in one of the ponds. We don't know if it was associated with the HAB or not. And then there was a whole bunch of turtles in another pond, and they were taken to the San Francisco Zoo. They were treated for, there was a bunch of dead ones, but there were alive that were treated for dehydration. And I think they're still looking into if those were associated with HABs. And we're working on some permanent postings similar to Santa Clara County parks, but we are interested in other options for having a single sign. We can maybe have an arrow or something pointing to what the designation of the lake is, because our park supervisors are tired of moving all these signs around, and we have so many access points to so many of our lake areas that it's a challenge to do all that. But anyways, I can answer any questions if anybody has any.
Hal, I would love to see some more information about your fish tissue study. Maybe you could present at one of the next CCHAB meetings.
Yeah, we could look into that for sure. I still want to. They want to come up with the protocols for collecting the tissue, because I think that's a really crucial part of this. There's been talk about, how to try to make sure you don't cross-contaminate and all that stuff. But yeah, we're going to work on that this year to try to get the protocols down to how to collect the samples so that, you know, we can be sure that they're isolated.
Okay, sounds great. Any other questions for Hal? All right, we are moving to Region 3. Melissa.
Hi, this is Melissa Doherty from the Central Coast Water Board, and I just have an informal kind of verbal update. Region 3 in my office participated in the FHAB statewide assessments for the pre-holiday sampling. So we participated in the pre-Memorial Day assessment at 4 different water bodies, and those water bodies are chosen partly because of their high use recreation and also because we've been sampling those water bodies at least since 2016. So that includes Lake Lopez, Laguna Lake, Lake Nacimiento, and Lake San Antonio. And in that assessment period, we recommended posting for caution at both Lake Lopez and Laguna Lake because of detections of microcystin, even though those detections were below the caution of 0.8. So typically in our region, we recommend the general awareness posting year round. But whenever we sample these lakes and have either visual indicators or microscopic ID of different cyano-producing species or any indication of cyanotoxins present, we typically suggest that they post the caution sign. In that assessment period, Pinto Lake was a collaborator, and they also sampled the lake at Pinto, and they had non-detects. So there was no recommended posting at that time. And we also had a volunteer researcher from the Santa Cruz Monterey area that collected samples at 6 different sites, and 2 of those sites, one at Monterey Wharf and at a Coast Guard dock, I believe also in the Monterey Bay, had anatoxins present at low concentrations, but again, we suggested posting based on the presence of those toxins. For the pre-Independence Day holiday, we again sampled those 4 lakes that we do typically every holiday assessment period in Region 3, which is Lake Lopez, Laguna, Lake Nacimiento, and Lake San Antonio. Again, we recommended posting of caution signs at Laguna Lake based on the presence of microcystins at a higher concentration. Again, the concentrations were below the 0.8. They were 2.2 for microcystins, but we also detected cylindrospermopsin and saxitoxin, so recommended the posting continue at Laguna. And we didn't recommend posting at any of the other lakes at that time because the rest were non-detects. And then finally, we participated in the pre-Labor Day holiday assessment. This time we sampled 6 different water bodies, and that included Lake Lopez, Laguna Lake, Lake San Antonio, and Nacimiento again. But we also included 2 additional lakes based on visual indicators that were described to us by some of our park staff and collaborators in the region. So Lake Santa Margarita was also collected during this assessment period, and so was Oso Flaco Lake. And unfortunately, all 6 of those water bodies were recommended for caution posting based on low-level toxin concentrations, and those range from microcystins, cylindrospermopsin, saxitoxin, and anatoxin. So that was the last round of sampling that we did for HABs, unfortunately, in 2021. Moving forward, we're hoping to increase our sampling at some of our regional or I should say region-wide monitoring sites this year in 2022. So we had proposed a special study a couple years back now to take HAB samples at some of our kind of routine surface water monitoring quality permanent stations throughout our region. And so we're really hoping to get that program up and running this year, and we'll be including HABs monitoring at those locations when there's visual indicators present. The only other thing that I think might have been new last year is we started collaborating with the city of SLO. They do kind of intermittent reporting at some of the reservoirs. Sometimes they test weekly, and they increase some of their sampling during, the seasons where we have more blooms. But they submit their data to us now and also to the CyanoToxins program. And based on different cell counts, we've had postings at some of those lakes that I had mentioned before, such as like Lopez Lake and Nacimiento. So that was a new collaboration in 2021, and we'll be continuing to get those reports in 2022 and hoping to maybe collaborate with some additional partners, at least for the holiday assessments again in 2022.
Thank you very much, Melissa. Are there any questions for Melissa or Region 3? All right. Do we have anyone to report on Region 4? All right. If not, we're going to go ahead and move to Region 5, and we have an update from the coordinator, Karen Atkins. We're going to have a Clear Lake report and also a DWR report from Brianna Sakata. So Karen, if you'd like to go ahead and.
It says that I'm disabled from sharing my screen.
Okay.
You should be co-host now.
All right. Sorry, there's actually two of me because I had to join on my computer and my phone. Try the other one.
All right. Making it tricky.
The one with the video.
Well, I don't see that on my screen. Sarah or Becky, do you see a second Karen? This is a new one. We are having all
Is it
kinds
your
of.
phone number, Karen?
I do, but I can't.
It's the not phone number one. It's the one with my name.
Yeah, and they both have video. Let me see if I can.
Oh, I think
I
one of them.
can see it if you want to make me co-host.
Yeah, I can't. I could see both, but I can't see how to make her co-host. I'm not sure I have that ability, Dave.
Yeah, I see.
I just searched on participants and I see two of her, and one's co-host and one's not. So
let's give that a shot.
And if that doesn't work, we can.
Yeah, I think Sarah has my slides too, or a slightly older version, but.
We can pull those.
Here we go. Maybe this will work. Try that.
Okay. Woohoo! Thank you.
All right. And stop being so tricky next time.
I gotta get an update to my computer. Let's see. Okay. Can you guys see my slides all right?
yeah, looks great. Thanks.
Yes, we can.
Okay, great. So I'm Karen Atkins. I'm the Central Valley FHAB coordinator. So just to hop right in, these dots that you see on the map are the water bodies that got bloom reports. So they are not the regular monitoring that we had going on, but just the bloom reports that we got. The red dots are those which were analytically measured. The blue dots were visual observations that people reported, and then the purple dots are those which were visual that were then followed up with analytical measurements. And the white dots are those that we just didn't have information on that particular aspect. If you kind of look at the clusters starting from the south here, we have sort of a Fresno cluster. We have then going up a little bit north, we have a ton of reports around the Delta, near Stockton, near Beth Island. We also have a lot near the North Fork American. Then of course, Clear Lake had a ton of reports. And then Lake Almanor actually had a late season bloom this year that you can see sort of in that north east corner of results. Now for routine monitoring, we had a whole range, a whole scale of people helping us. So thank you to all of our partners. You can see regional parks. We had 2 different tribes helping us. We had also even a company, Nautilus, that was monitoring around their facilities. So to dive a little bit more into those results, some of these people were, or some of these groups were monitoring cyanotoxins, or all of them were monitoring cyanotoxins. Some of them were also doing cyanobacteria ID, but not all of them were. Clear Lake had a ton of sites that the Big Valley Rancheria and Elm Indian Colony were monitoring, and they had a max advisory of danger. And then the East Bay Regional Parks, Hal just kind of covered, but they were monitoring at 2 sites in our region, and both reached danger level at some point during the summer. us at Central Valley Water Board had a couple different sites we were monitoring, Discovery Bay, and then Hensley and Eastman. And those also, 2 of them reached danger and 1 got to a caution. Kern County was monitoring Lake Isabella at multiple sites, which reached a warning. Nautilus Data Technologies were monitoring 2 sites around their facilities, one in San Joaquin River and the other in Stockton Deep Water Ship Canal, and they reached lower advisories there. And then DWR had a range of sites and a range of advisories that went all the way from danger to no advisory at all. We had several beneficial uses that were impacted. As you can see in the photo, we had a fish kill at Hensley. And then we had tribal, traditional and cultural uses that were impacted, as well as some fishing, of course, water contact, and wildlife was also impacted. Unfortunately, we were asked to speak on mitigation measures. Unfortunately, we don't actually track mitigation measures at our region, and we don't usually recommend specific mitigation strategies to those who ask, although we can provide, just general resources to them. I do anecdotally know of a few different groups that were doing small scale algicide applications, mostly at private lakes like golf courses and that sort of thing. Some exciting things to look forward to for 2020. So first of all, we're doing kind of an internal adjustment just at Region 5 of how we're handling incident responses. Most excitingly, I think, is that we're hoping to use SFEI's satellite data tool to a larger extent to sort of be able to do advisories and monitoring before people actually get harmed. In addition to that, we're trying to increase our partner monitoring for cyanotoxins. Some of the highlights of that effort is that we're going to have Restore the Delta monitor several sites near Stockton. 7 sites are the current plan, but there's a little wiggle room there. And they'll be doing that weekly for 5 months during the summer. And then California State Parks will be kind of monitoring that North Fork American River cluster that you saw on the map. They're going to do about 4 sites, maybe add more, we'll see, every other week for 4 months. And then in addition to that, we're expanding our study at Hensley and Eastman Lakes to include some eDNA work, get a little bit of a better understanding of what's actually in the lake. We're also going to be doing some benthic algae monitoring because this year, while people were monitoring, they noticed that there was some benthic algae on the shorelines, and we hadn't previously looked at that. In addition to that, SFEI's satellite tool, which I previously mentioned, is getting some results that we thought were a little bit funny at Hensley Lake. And so we're going to be using some of the data we collect to sort of better understand what that tool is doing and hopefully improve it a little bit. And in addition to that, we'll continue our cyanobacteria monitoring at that location. Thank you. Any questions?
We have a couple more reports for Region 5. And if there are any questions for Karen, I'm going to go ahead and share my slides, Karen.
Okay. Yeah, stopping share. There we go.
Okay. So if there are any questions for Karen, go ahead and raise your hands. All right.
Hey, I'm looking for the hand raise button. Sorry, I couldn't find it, but I had a quick question for Karen.
Oh yeah, go ahead.
So you'd mentioned you hadn't been tracking mitigation measures in your slides. Is it because you don't have the bandwidth, or is there what kind of reasons do we have there?
It wasn't really part of our program up till now. Maybe Marissa and Carly would be the people to ask about that a little bit more.
Okay, copy. Thanks.
Hey, this is Marissa Van Dyke. Karen addressed the question for me and Mike. For mitigation measures, we don't have a formal tracking system in our existing database to keep track of all that kind of information. But with our modernization effort of having formal data structure, that's going to go live in mid-February. We are going to be building a module for tracking mitigation. So that's a place where we can house it. But just without a data system, we could be aware of mitigation measures, though it just depends on if that communication is happening with the regional water board coordinators from water managers that are, or land managers that are implementing mitigation measures. There's the statewide algae application permit, and that's handled in another division. We sometimes do review those applications, then we're a little bit aware of that, of what might be occurring. Again, many entities apply for it just in case they need to use it. So we're just not aware of actual mitigation measures and like pre or post monitoring. But if that's something that CCHAB members would like to share, particularly maybe through the mitigation subcommittee or directly with local HAB coordinators, that information, we would like to learn a little bit more about that. So you can share it again to the cyanohab.reports email to get in contact with who your coordinator is in your regional area, or share it directly just with the statewide email inbox if you'd like to.
Okay, thanks a lot.
Yeah.
Thanks for that question and answer. Okay, we'll go ahead and move. Now, we are running about 10 minutes behind, so we will take our break as soon as we finish the regional presentations, and then we will move into the ecology of cyanobacteria presentation. That one is going to be a 30-minute, so we'll have a chance to, we'll probably be starting with her about 10 minutes later than is on the schedule. So the next Region 5 report, we have a short report for Clear Lake. What you should see on the screen is the sites that we sample the most. There's some sites that we only do a few times a year from our partner monitors. The county and UC Davis also provides us water samples from their project. And you can see throughout the summer what the caution, warning, and danger toxin levels were based on, of course, the guidance. And we've also looked at the number of times that the sampling events at that site were at caution, warning, and danger. So you can see in this final column that we've got some sites that every time we were out there in the summer and submitted the samples for analysis, that they came back at caution, warning, or danger. You can also, we have 3 distinct arms of Clear Lake, and that's what the arm column is. We also had 2 sites, all but 2 of the sites were at elevated levels more than 50% of the time that we sampled. This next slide is pretty busy, but it is part of our report that we'll be sharing, which has the microcystin and anatoxin levels for each site for all the sampling events throughout the year. So we started in April and ended in December. We were very busy with anatoxin analysis this summer because we had multiple sites with anatoxin and producing cyanobacteria. The red highlighted cells are the highest, sorry, let me find that. The reds have the highest toxin value for that sampling date, so that you can see, I'm sorry, the dotted, bolded cells are the highest value for that particular site. So that you can see that in September, we had a lot of the highest values happening September and early and mid-September. The highest value that we did see for microcystin on the lake was something that was higher than any of our years of doing cyanotoxin monitoring. It was 160,377.5 for microcystin. We also had an anatoxin highest level, which was in October of 35.42, which is at a warning level of anatoxin. We also created a map of the most frequent toxin level for each of our regularly sampled sites. And you can see in the lower arm of the lake that all but 1 site were most frequently in the danger levels of microcystin, and the Oaks arm, most of the sites were in that same condition. And finally, a little bit more about our antitoxin detects. We've got a little bit of microscopy. We do microscopy for each of our sites and each of our samples. And you can see that this one particular site, Shady, which is the site that is Cache Creek heading out of Clear Lake into Yolo County, had increasing higher levels of antitoxin. And in October, actually, we also had, it started to drop. We do have some antitoxin, so we're continuing with our winter monitoring, and we have antitoxin levels from our last sampling event in December. We did see mostly throughout for the antitoxin detects, Planktothrix, and by the end of the season, we started to see a lot more Famazomicon. So it's just something that we're continuing. And that is the end of our, I'm sorry, and one other thing is that because of the drinking water, we do have some private intakes on Clear Lake, and because of the toxin levels on the lake, there was a health advisory that came out from our public health officer who recommended that all the homes that have private drinking water intakes in the Oaks arm of the lake, which I'm circling here, and also the lower arm, that they do not drink their water. And that was in effect from mid-September to I believe late November. It's now been lifted, but there are concerns about the vulnerabilities of the private drinking water systems on the lake. We have a presentation on that later in the on the agenda. So are there any questions? Otherwise, we'll move to a DWR report from Brianna. All right, go ahead, Brianna. And I might be mispronouncing your name. I apologize. Is it Brianne?
Hi, can you hear me okay? It's Brianne, actually.
Thank you.
Oh, no problem. Yeah, just have a short update for our state water project facilities in the Central Valley region. At Lake Oroville, we monitor once a month at a site near the dam from April through October, and we did not detect any cyanotoxins during the 2021 season. We also monitor in Thermalito Forebay and Thermalito Afterbay at the swim beaches, and that monitoring is weekly from Memorial Day through Labor Day, and we did not detect any toxins at those sites either this season. In Clifton Court Forebay in the South Delta, we did not detect any toxins this season either. We monitor in Clifton Court Forebay at the inlet and also at the outlet. And yeah, no toxins this year in our twice monthly monitoring, despite there being blooms in the South Delta. Moving south to O'Neill Forebay, we did have a caution advisory posted in O'Neill Forebay from July through November due to the microcystin concentrations. And San Luis Reservoir, we had a range of advisories there based on the microcystin concentrations. We first posted a caution advisory in June. It increased to warning in August, then to danger in September, then back down to warning in October, and finally back down to caution in late October. And we were detecting microcystins all the way through the week of December 6th. And then we finally had 2 weeks of non-detect and pulled the caution signs the week of December 20th. And we're now done monitoring for the season. And we plan to start back up again in April. That's all I have.
Thank you very much for that. Are there any questions for Brianne? All right, we will go ahead and move into Region 6 report. Go ahead, Sabrina, and pull up your slides.
Morning, can you guys hear me?
Yes, we can.
Okay, good. I tend to have difficulties with Zoom and my audio sometimes, so I'm starting to share my screen now. Can you guys see it?
Yes, we can.
Okay. Oh, shoot. Oh, there we go. Okay. So I'm Sabrina Rice from Lahontan Water Board. I'm the FHAB coordinator for our region. And this season we did quite a bit of monitoring, and I have, the type of monitoring we conducted here. So we did, assessment of new and recurring blooms, incident response, and I realized that I didn't put the pre-holiday assessments on this list, but we participated in all three of those. And then we did some special studies in our region to evaluate a laminar flow aeration system in the Tahoe Keys. And then we are doing some sampling in high elevation lakes, and eventually we hope we can develop some risk criteria for high elevation lakes. And then State Board actually partnered with the Swamp Bioassessment Program this year to perform algal mat sampling, and that was across the state, but there were several locations in our region. And so we had around 160 samples taken total this year at 36 different water bodies and 22 advisories. And all of this, again, would not have occurred without all of our partners. So thank you to everyone who participated. We're very grateful for you. And this is a little bit of a busy slide here, but we have, I have all the advisories on this slide. And so it has the water body, who sampled the water body, why it was sampled, when the advisory occurred, and the advisory. So we had 3 danger advisories. 2 were in Mono County at Bridgeport Reservoir and Crowley Lake. Those are on the eastern side of the Sierras. And then 1 was a DWR lake in Los Angeles County at Quail Lake. And then 1 warning was Silverwood Lake in San Bernardino County. And then we had 1 dog illness report at a pond near Donner Lake. There's a campground in this area, and this pond is near that campground. There's several little ponds in that area. And then we did have some difficulty sampling certain areas this year due to wildfires and Forest Service closures. So we had several cautions just based on visual observations, just because we were getting those reports still. And yeah, and then our beneficial uses impacted were Rec 1 to municipal supply, tribal and cultural uses, and agricultural supply. And next year we just continue, or we're hoping to continue, our incident responses, our special studies, ambient monitoring, partnership development, and then collaboration with State Board and other regional boards to identify longer term needs for the program. And that's all I have. If anyone has any questions.
Thank you very much, Sabrina. Any questions for Region 6? All right, we'll move into Region 7. Is there anyone to present for that? All right, so we'll move to Region 8. And Katie?
Hello.
Hi, are you you're gonna be sharing your slides?
Yeah, if that's okay.
Perfect.
We'll go ahead and do that. Sorry, I'm still used to Teams, so every time I use Zoom, it takes me a little moment. Oh, there it is. Right green button. Okay. Okay, which screen am I sharing?
You're sharing the screen with the next slide showing as well. So not the presentation screen.
Let's change that. There we go.
That works.
All right, so my name's Katie. I'm the FHAB coordinator for the incident response at Region 8.
And the following is what we've been working on this year. So this is kind of just a map of the different lakes that we've been sampling. They're color coded. So the ones that are brown, they're part of the holiday assessment that we did with San Bernardino Parks. Red was incident response and purple was our HABs special study that we've been working on. So for the holiday assessment, it was with San Bernardino Parks. They were the ones who took the samples, and like the levels of microcystin ranged from caution to danger throughout the year. For Glen Helen, data was sampled in May and a danger advisory was recommended. Prado Regional Park, the first holiday assessment, the data was not received by the lab, but we were eventually able to get samples in June and results detected under the advisory threshold. And then finally was Yucaipa Regional Park. This was the one that they sampled the most. Data was sampled in May, June, August, and September. May and June, there were non-detects. August, Yucaipa Regional Park was urged to post a danger advisory for the entire park. And then in September, the microcystin was non-detect. However, antitoxin A was detected, and therefore we recommended a caution advisory for the whole park. For the incident response, we only had 2 incident responses this year that did not relate to Big Bear Lake or Lake Elsinore. Again, those are part of our special study. So if we did receive a report, we just put those in and sampled them along when we took our special study samples. So out of the 2 that were an incident response, only Lake Evans was sampled. And microcystin and antitoxin A were detected, antitoxin A within the caution advisory and microcystin within the no advisory range. So here's more information on our special study. It's gone from 21 to 2022 at Big Bear Lake and Lake Elsinore to conduct routine FHAB monitoring to better understand trends and relationships such as nutrients, chlorophyll A, that one, and then field data. In 2021, Big Bear Lake was sampled once a month from May through November at 6 locations. And then Lake Elsinore was sampled twice a month at 2 locations, May through December. The special study will conclude in fall 2022. Results could guide decisions for the 303D impaired water body listings, the TMDL development, and other regulatory actions. It may also improve lake management strategies and timely public notifications. So these are some of the results from Big Bear Lake over the past year. As you can tell, it peaked in August of 21. The following results were tested but were non-detect, and that was antitoxin A, Cyanobacteria, and saxitoxin. And then the peak again was microcystin in 2021 with a warning advisory. For Lake Elsinore, the following were tested, but results were non-detect, and they were the same ones as before. Antitoxin A was detected at 0.18 in October of 2021. However, the map, it was so far below the trends that it didn't show, but it was there. And then the peak in the microcystin in November 2021, and it was a danger advisory. And that's it for Region 8. Are there any any questions?
Looks not. Thank you so much, Katie. It was really interesting. Good information. All right, we're moving to Region 9, and Debbie will be pulling up the slides for you. Dave, are you pulling up those slides?
I was not aware of that. Let's see if I can do that. Are those coming through?
Yes, thank you. All right, Debbie, go ahead. Thank you. And you are muted too.
There we go. Okay. Yeah, well, I'm Debbie Woodward. I'm presenting today because our FHABs coordinator, Carrie Nagoda, couldn't be with us. She's at a hearing at the state board. Yeah, I'll be presenting for her, and she and I did all this sampling together. So our Region 9 activities are in 4 categories: the pre-holiday sampling, emergency response, something we like to call our region's problem child, which is a reservoir with a very persistent bloom, Lake Henshaw, and we did a special study. That picture there is one of our reservoirs, Lake Marina. I'll be mentioning that throughout. Next slide, please. So for pre-holiday sampling, we did 3 holidays. They're up there: Memorial Day, July 4th, and Labor Day. We did 4 sites chosen for their recreational use. Santa Margarita River swimming hole. There's some cool waterfalls on Lake Penasquitos Creek. San Diego River at the Old Mission Dam. That's a sort of a lot of dogs splash around in that water. So that's sort of more dog than people. And then Marina Reservoir. And for all of the sampling, we only got 2 detections. Those were of Cyanotoxin A for the Labor Day sampling. So those ended up being posted at the caution level. All right, next slide, please. For our emergency response, we had 4 events. They were sort of in the fall of last year, November and September. 3 were on the San Diego River at various spots, and 1 was in Marina Reservoir. They were in response to, we did 1 pre-holiday follow-up on the San Diego River Old Mission Dam. 2 were in response to public reports of a fish kill and a potential bloom, and 1 was follow-up to a satellite notification. I'll just skip to the results because all of the toxins were non-detect. And we did have low amounts of some mat species that are listed there in the right-hand column. And only 1 site, the Marina Reservoir, ended up with a caution for high amounts of Planktothrix. Next slide, please. Okay, this is our problem child, Lake Henshaw. It's had a Cyanobacteria bloom since summer of 2020. So initially we sampled it, but since then the Vista Irrigation District has taken over and done a wonderful job. They're doing weekly toxin sampling and they're sharing their data with us. It's great. Yeah, so they've had caution or higher levels since summer of 2020, mainly due to microcystins or Cyanotoxin A detections. So Lake Henshaw is in the northern part of our region at the base of Mount Palomar. If you know where that is, there's a picture of it. It's an obvious bloom. And Carrie found this graph from Vista Irrigation District. It can give you an idea of the levels of the toxins we're finding. So on the left, it's concentrations in micrograms per liter on a log scale, and then time at the bottom starting in June of 2020 and going to last month of December of 2021. You can just see that the microcystins peaked. They're the green line. They kind of go up and down, but there was a time where they were above the danger level threshold. And then Cyanotoxins are the purple line. They've been going up and down. And temperature is the brown line. If you just go to the far right of the graph, you can see that we are still currently, Lake Henshaw still has Cyanotoxins at above the caution level. Microsystems have dropped a little bit, but both of them are present. So we're dealing with that. And the Vista Irrigation District has hired Stillwater Science to develop a mitigation plan. And I know that they are, I think they have received, actually, they've applied for and received an aquatic pesticide application permit. So that's sort of in the process, what they're going to do about it.
Hey, this is Jenna.
Okay, next slide, please. And finally, we had our special study. We did a screening study for cyanotoxins in streams that were in high agricultural use watersheds. So we did 9 sites. 7 were in the Santa Margarita River watershed. Those are the 7 at the top of the map. And then 2 were in the San Luis Rey watershed, and those are the 2 on the near the lower down on the map. So we did those 9 sites, and we deployed spats, 3 sets of spats, 1 spat at each site, 10 days apart. So we did 3 10-day spat deployments. And basically it was the month of July 2021 that we covered with those 3 spats. We also did at each site microscopy for the Cyanobacteria species and water grabs for the total nitrogen and total phosphorus, and in situ measurements of normal field measurements, temperature, pH, DO, and specific conductivity. So the pictures, I wanted to point out how we deployed the spats because it worked so well. We used little plastic pots. They're 4-inch plastic pots, normally used for hydroponics and also orchids, something like that. But they're you can get 100 of them for $25 or something. So it's really inexpensive. And they're, if you can see the picture on the left, we have a spat that's kind of nested between two pots at the bottom. We put them in nested between there, and that really protects them well, yet leaves them exposed to the water very well. And then we just zip tied the pots together, and then zip tied those pots, that set up to a stake, and then deployed it into the stream. We had really good luck. We lost only 1 setup because somebody pulled it up. We're just starting to look at the data, but I've listed the species that we have found over on the lower left there. Those are the ones that have been ID'd. We have detected 3 of the 4 toxins that were tested for at those levels listed. Those are the highest levels we found. And toxins were pretty widespread. We found them detected in all 9 sites, in 22 of 26 of the samples. Again, that should have been 27 samples, but we lost the 1, so 26 samples. And just to give you an idea, at one creek, this is the creek, Murrieta Creek, that had the highest microcystin levels. The 3 spat measurements were, the initial one was a non-detect, the next was an 8.87, and the last one was a 14.38 nanograms per gram. Anyway, we're starting to look at the toxin, nutrient toxin relationships, and we will write that up or present it at a later time. It's going to be very interesting. And for future, that's all I have on these. And for future sampling, we just had so far we have 4 reservoirs in our region that have blooms or that are registering on the satellite imagery. And 1 came in today, so a 5th one. So we'll be probably going out and field testing that 5th reservoir, which is Otay. That's it. If there's any questions.
Thank you so much, Debbie. Any questions for Region 9? All right, we're going to move into a shortened break because we are running behind. We're still probably okay, but let's take a break until 10:55, and then we will start with the 10:30 scheduled item, Introduction to the Ecology of Cyanobacteria. See you in 5 minutes. Hillary, are you there? I'm trying to send a chat to you, but I want to make sure you're ready to go.
Sarah, are you on?
Yes.
I wonder how we're going to pick up that much time. You think we should just push everything? Is that what you're thinking?
Yeah, we're going to take a little bit shorter lunch. We're taking a shorter break, and
yeah, we'll be reasonably close then.
Yeah, we're about 15 minutes behind.
Oh, is that all? Okay, yeah. Great. Good reports. I mean, I liked them. Just they went on. So let's see. So we have the CalWATCH update and the OHA. Okay.
The next update is the 1031, Introduction to the Ecology of Cyanobacteria. So Hillary is going to pull her slides up.
Okay.
Oh, there we go.
And I believe, yeah, I already made her co-host. Very good. Thank you.
All right, we're going to go ahead and get started. We are running about 15 minutes behind. We're going to catch up a little bit with this presentation, and we're going to take a little bit of a shorter lunch. But prior to that, we have a drinking water and HABs update as well. So Hillary, we are really honored to have you on. And I know that George was on the agenda and he is not available to present today, but we look forward to your presentation. I originally saw your presentation at the NOLMS conference this year. It was fantastic. So let's go ahead and take it away. And the questions you'd like questions at the end, is that correct?
Yeah, I think that would work best.
Okay, wonderful. Thank you so much. Go ahead, Hillary.
Awesome. And I'm just making sure everyone can see my introductory slide right now.
Yes, looks good.
Yeah. Okay, great. So thank you everybody for having me here today. It's actually been really interesting to see how California does things. It's a lot different than the eastern part of the US and what I'm used to. A lot of the monitoring for toxins is done only when there's really bad cyanobacteria blooms, and oftentimes we don't even get the results and they're not publicly posted anywhere. So it's really nice that you have those systems set up where people can go and check and see what's happening in their local communities and lake systems. So I am going to preface this presentation with the fact that our workshop had a lot more information in it. And it started generally with George's long introduction to limnology and how limnological principles apply to phytoplankton succession and eventual cyanobacteria dominance in the water column. I also saw that you guys focus a lot on benthic cyanobacteria and benthic mat growth. This does not apply to benthic types of cyanobacteria, or primarily benthic types. It is an introduction, so I assume you guys will have more questions, but if you're interested in taking the workshop, we do it with the North American Lake Management Society on an annual basis now in November. So just to start, I like to, when I speak about cyanobacteria, try to zoom out first and recognize that in trying to manage cyanobacteria and keep people safe for recreational purposes, we have to acknowledge the fact that they're way ahead of us. They're billions of years ahead of us. They've been around for about 2.5 billion years, and they were responsible for the Great Oxygenation Event, which essentially transformed our very methane-dominated atmosphere into a higher percentage of oxygen atmosphere that allowed all creation of life on Earth. So I think it is good to take a step back and also acknowledge that these guys deserve a lot of credit, despite the fact that they're a very nuisance in some cases. They are naturally present in all water bodies in low abundances, and it is only until they become very prolific that they start to be a problem for recreation and economies and public health. I saw a lot of the toxin tests that you guys were getting were actually very low and non-detect, which is very common to what we get, even in a bloom that looks very bad sometimes. And of course, we call them blue-green algae or HABs, but they really are these photosynthetic prokaryotic bacteria that use light and nutrients to create their own food. So to start a little bit with the limnology part here, it's really important to understand motion of water in lakes, and the fact that lake systems are very temperature and light dependent systems, where it's really the light of the sun's rays that creates the temperature changes in the lake from year to year. So this is a figure that taken from the Encyclopedia Britannica that shows a typical dimictic pattern of warming and cooling and the stratification that ensues, where just in case some people aren't familiar with this, in a typical system, you would start the spring with about a uniform temperature from the top to the bottom. And as the summer temperatures increased, you have the development of an epilimnitic layer on top of a hypolimnitic layer. That epilimnion is a layer that is less dense because it is warmer, and the hypolimnion is much more dense and it is cooler, and then separated by this thermocline in between, where not only is the temperature difference great with depth, you also have a huge density change with depth. And it's that density change that's going to be really important for cyanobacteria becoming dominant in certain types of environments and lake systems. Polymictic lakes, which are probably more common in the more southern locations in California, or sometimes partially polymictic lakes, which are lakes that go through multiple periods of mixing and stratification, and sometimes those stratification events are what we consider moderately stable or weakly stratified, where I'll talk about this in a second too, but the stratification in a normal dimictic lake is very strong. It takes a lot of energy to overcome that kind of a stratified system where the density gradient is so great that any large storm is still incapable of eroding those density barriers. But in polymictic lakes, where you have more weak stratification and a less intense density barrier, a lot of times you have huge storms that come through, or even just regular wind, like up to 20 knots or something, that creates enough energy and puts enough energy into a system that forces water of different densities to mix through turbulent flow. And again, this is what drives cyanobacteria. So the natural seasonal succession of phytoplankton, and this is oversimplified here, it's different for different kinds of lakes, but this is general what is accepted in science community, where in the spring you have dominates by diatoms, which are very large bodied phytoplankton, and they're also very heavy, and they, despite the fact having really high growth rates, they need those mixing conditions in the spring and the fall to be able to keep themselves suspended in the water column. And in the summer, as the temperature gradient starts to develop and the stratification starts to develop, those blue-greens are going to be the only ones that are capable of overcoming those density gradients. So it's the diatoms and the greens and the chrysophytes that end up falling out of the water column. And because cyanobacteria have this miraculous ability to regulate their cell density, that is why they're able to regulate their buoyancy or their height in the water column. And it really just gives them a huge evolutionary advantage over other types of phytoplankton when the water is warm and stratified. The RTRM value, or the relative thermal resistance to mixing, is a pretty decent way of trying to quantify how intense the stratification is. And it really is just giving you a number or a ratio of the difference in the density from one layer to the adjacent layer. So this is calculated here at 1 meter increments, and you can see that there's, as the season progresses, a higher and higher density gradient in the middle of the thermocline here. And RTRM gives you a good indication of where the metal and neon, or where the thermocline actually is and what its strongest points are. Sometimes in polymictic lakes, what you would see, instead of this one seasonal progression, it would go back and forth between a very low RTRM where there is water column stability. You do have some level of stratification that may favor cyanobacteria, but then it would go back and forth with the wind mixing event like this. And those types of back and forth between stratification and mixing events oftentimes allow cyanobacteria to take advantage of nutrients from the sediments and mix nutrients from deeper waters into the over epilenitic area. So sometimes also you don't really need very strong stratification for cyanobacteria to dominate. I'm pretty sure everybody on this call has already seen this figure and understands how scums form, but I'm going to go over it now because I wasn't sure exactly who my audience was today. But this shows how cyanobacteria start over a large volume of water. And as the temperature gradients develop, sometimes cyanobacteria are going to, in search of light, migrate to the surface. And when that happens, the volume of water is reduced, and you essentially have a concentration of cells that can sometimes get stuck on the surface and then blown into the coves. And monitoring shoreline scums is the frequent thing that people do to try to determine public health risk and see if there are toxins present in swim areas. But it's also really important to understand what's going out in the center of the lake and in the vertical profile of the lake. So I'll talk about monitoring in a few slides. Essentially what's happening is that the cyanobacteria are just responding to their environmental conditions. And they're responding to the availability of nutrients, yes, but they're also responding to the light and lack of wind and the temperature-driven stratification to allow them to move to the surface. If they move to the surface and there's not enough nitrogen or phosphorus to sustain a bloom, generally it's really short and you don't have those huge conglomerations of scums on shore. So I took this clip from the Cali California mywaterquality.gov website. And I thought it was interesting because we always talk about how nitrogen and phosphorus are the primary growth factors in cyanobacteria and HAB blooms that we see, which is true, but also it's the fact that cyanobacteria are the only type of phytoplankton that frequently outcompete the other types of phytoplankton, where if we had inputs of nitrogen and phosphorus in enough amounts to grow lots of types of phytoplankton, but the water column stability was not favoring cyanobacteria, you would see other types of dominating phytoplankton, like chrysophytes or diatoms or green algae. The bloom forming cyanos form these scums because they float, which is how they're responding to their environment by producing these gas vesicles. And Walsby was the guy back in the 70s that most of this original research was attributed to. So he had a lot of publications examining through electron microscopy about what the shape of the vesicles were, how large they were, how they were arranged in the cells, whether some were stronger or weaker. And he discovered that vesicles are produced in low light scenarios. So they're produced when the cyanobacteria need to generate some ability to migrate to the surface. So in low light conditions, you're generally in the cooler, deeper waters and not in the epilumnetic waters, or in the very surface layer at least. And when in the denser, colder waters, the cyanobacteria has to compensate for that density gradient. So it creates these vesicles, but as it moves upwards, that density is going to decrease in the water column as you start moving upper and upper into the shallow waters that are warmer and less dense. And that sometimes creates an acceleration of the upwards momentum of certain types of cyanobacteria. And that is one of the major reasons why they get stuck at the surface and cause these shoreline scums and blooms like that. Certain taxa have different buoyancy rates and different abilities to control their vesicles. Some of it is related to vesicle size, some of it is related to vesicle structure, in that the certain types of vesicles are more difficult to collapse than others. And when I say collapse, I mean that cyanobacteria have the ability to, in lit situations where they're actively photosynthesizing, increase the turgor pressure within their cell to a point that can collapse vesicles. And they can collapse this enough to slow their growth as they're moving up. And sometimes it doesn't go as well and they get stuck. When talking about blooms, you guys are showing a lot of different pictures of benthic cyanobacteria and or wispy surface scums, but I always like to know what kind of bloom it actually is, because I think the type of bloom that you're seeing is extremely relevant to how you're actually going to manage it or attempt to manage it. So that also begs the question, well, what is the difference between a bloom and a scum? Is it only considered a bloom if it forms a scum, or is it considered a bloom if you see an accumulation of cyanobacteria somewhere in the water column, not necessarily on shore and not necessarily in a concentration that is detrimental to public health? So with that, I have 4 that I like to give. The first is the epilumnetic growth. So this is the fact that you have enough nutrients in the water column in the epilumnion to create cell divisions, and eventually they will migrate together to the surface. The second is metalimnetic growth, where certain types of cyanobacteria like to hang out in about right above the anoxic boundary. Sometimes this is towards the bottom of the thermocline. Occasionally I've seen phycocyanin spikes in towards the top of the thermocline as well, but most of the time it happens right at the bottom of the thermocline at the top of the hypolimnion, because that is an area where usually there's a lot of nutrients being loaded from deep water. And sometimes these deep waters are anaerobic, which creates a more internal recycled nutrients that cyanobacteria can take advantage of because they have the ability to move upwards and downwards. And sometimes these will never move to the surface, but occasionally they do, and sometimes it happens without warning. So in terms of sampling, it's important to understand what type of blooms are actually occurring at your lake to be able to predict how it's going to happen. The third is benthic growth of planktonic forms, followed by all of a sudden a recruitment to the water column. And sometimes that recruitment is just to the water column, and sometimes that recruitment is all the way to the surface in what we call a pop-up bloom. And usually if it goes from being entirely almost absent in your samples to prevalent on shore and fairly large colonies, usually it's either a Dolichospermum bloom or an Anabino bloom that came from its resting stage and then ended up in the water column and migrated to shore. Pop-up blooms can happen in lakes that have relatively low concentrations of nutrients. So we've seen certain types of cyanobacteria bloom in lakes that have on average less than 12 parts per billion of phosphorus, or should be really considered oligotrophic lakes. The fourth type is, of course, the benthic mats, and for the most part, they do try to stay in their benthic habitat, but occasionally in very eutrophic systems, they do start to break apart and they create enough upward rise and gas to allow them to migrate to the surface where they can become more of a public health concern. The recruitment of cyanobacteria is different based on what type it is. So only certain types of cyanos form resting actinids. So those are those specialized cells that rest on the sediment surface and allow cyanobacteria to withstand very low temperatures. So in the winter conditions, a lot of times Anabina and Aphanizomenon species will create these actinids that will then rest and be ready for the nutrients, light, and temperature conditions to be able to sprout. And at which point they go through a benthic phase of vegetative growth where they're on the surface of the sediment. And at some point, whether it be to temperature, light, nutrients, anoxia, there's even some papers out there that describe the interaction of other types of microbes in the actual recruitment to the water column phase. But recently I've seen a lot of publications about resuspension and bioturbation, where you have to have some sort of physical movement to release many cells all at the same time. And I've seen it happen by wind mixing events in early spring blooms that we weren't expecting. And I've seen it happen in certain cases where all of a sudden the bottom was disturbed by a boat or by a person walking through, and then very, very quickly you can see the cyanos migrating from the sediment to the surface. So you can form a bloom in that way in less than a 15-minute time period. So it is super variable from one part of the lake to another and within time. And then of course, some types of cyanobacteria produce these heterocytes that are specialized cells that fix nitrogen from the atmosphere. And it's very expensive for cells to produce these types or to use nitrogen fixation as a method of attaining nitrogen. So they don't do it as readily as you would expect. And then eventually it'll fall back to the bottom. But certain types of cyanobacteria don't have the aconite form. So microcystis is one of those ones that we see all the time and usually associated with high toxin concentrations. That does have an overwintering benthic form, but it's a vegetative form. It doesn't have those resting cells. Instead, they produce these mucilaginous colonies that keep themselves on the sediment surface, also waiting for the temperature, light, and nutrient conditions to bloom and recruit into the water column for vigorous growth. When it comes to monitoring, I think it's really important to understand what your sample is capturing. And I know that a lot of the public health programs start by understanding what the public health risk is in a shallow shoreline area, and in the swim area, you want to know what the concentration of toxins is. But I've also taken toxin samples in swim areas in triplicates or redundancy, and it really varies from one place to another. So for instance, one of the scums that I was sampling had upwards of a 10 microgram per liter difference in toxin of microcystin from only 10 feet away from each other. I don't know if that influences health decisions or anything, but I thought that was pretty interesting. And it doesn't seem like that kind of variability is well reflected in the health literature. But anyways, it also, if you're going to try to tackle managing cyanobacteria and you're not just going to keep closing the beaches every time there is a surface scum, you really have to be monitoring out in open water. And if you're doing so, you gotta know what type of what type of cyanobacteria you have and what occupies or what space it occupies in the water column. We do our samples with the 3-meter National Lakes Assessment EPA method, but we know that that's not always appropriate. Certain very clear lakes that might be more dominated by the metallinetic types of cyanobacteria would require more depth specific sampling versus a lake that has or is well known to have pop-up blooms. You might want to integrate more of a benthic survey at a certain point in the year to understand what's coming or to target any kind of treatments or mitigation measures. I put a note here about toxins and cell counts. So California is one of the only states that's regularly collecting toxin samples from a lot of different lakes across the state. Certain states do a lot more cell counts, and I've had issues over the years with trying to use the old World Health Organization recommendations that try to attribute a cell count density to a certain toxin density, and almost never does it seem to compare. And I think a lot of that is due to the fact that
Want to listen to this? Should I play it out loud?
So certain types of cyanobacteria are much smaller celled than others. And so the biomass can still be high, the toxin quantity can still be high, but the cell quantity can be high, but the toxin might not be as high. The new 2021 update to the WHO publication has a really, really awesome guidance about all different ways cell size and cell volume affects the growth of cyanobacteria. Looking at how the surface area to volume ratios affect their ability to use nutrients and uptake nutrients from the water column, where the small cells are more efficient. Small cells also tend to be better at regulating their buoyancy and are less likely to get stuck at the surface. So that's one of the reasons why you don't really see Planktolyngia, or sometimes you see Chrysosporum blooms at the surface, but in my experience, it's always less frequently than you see Rhonotrinia or Inabina or Microcystis. And then, of course, different types of cells require different light for growth, and they tend to occupy various locations in the water column. When are toxins present? That's like the golden question that everybody seems to be trying to understand these days. And really the reason is we don't know. If the chance of having high toxins is much greater if there's a high number of cells. So if you can stop the blooms from accumulating on shore in high quantities, the likelihood of toxins goes down dramatically. Toxins, I talked about how you can have a huge variation between one side of a beach to another in toxin concentration. Gene expression is a huge realm of research right now, and looking at the possibility of quorum sensing and environmental response in cyanobacteria genes to decide when they're all going to turn on toxin producing genes. I'm not a microbiologist. It fascinates me, but it gets really complicated quickly, so I'm not going to touch upon that much more. And then, of course, you do have the theories out there associating nitrogen and carbon, or a lot of other types like vanadium or molybdenum as being micronutrients that are valuable and required in the cellular processes required for toxin production. A lot of research is linking the fact that end storage in toxins, because the toxins themselves tend to be nitrogen heavy molecules, is one of the adaptations that is the reason why the toxins are produced in the first place. So if there's an overabundance of nitrogen, chances are you might have higher toxins. There's a lot of research out there, and I implore you guys to go read the 2021 World Health Organization publication if you haven't already. In terms of management, I wasn't sure if I was going to put this slide in here because I don't know what the rules are in California about management, but I generally talk about it in 3 different ways. So you can kill them with algicides, which is an extremely temporary fix, and it usually works best for a shoreline area or to try to keep a beach open for a period of time. But in our experience, it's been usually less than 3 weeks. And if the nutrient concentrations are high, an algicide might be required every 2 weeks in order to keep a heavy blooming lake open for recreation. And in that case, some regulatory agencies are also worried about releasing toxins into the water column and the presence of having toxins in open water because the cells have died, but then not actually having that visual reference as well. So that is a concern. You can try to outcompete them somehow, where trying to make them sink or try to stimulate conditions in the lake that promote other types of algae like diatoms or green algae. I've even seen not good references, but there's been cases in the lake management community where people are trying to predispose a community to other types of bacteria, or to use bottom up or top down biomanipulation, but I think those are very limited. So ultimately, you really need to take away the nutrients. And I know that I heard that there are several aeration or hypolinitic oxygenation systems in there. And I'm hoping to publish some new research on an aeration system that I'm working on right now. But there's a lot to suggest that aeration and oxygenation alone are not always going to control cyanobacteria. And in many cases, the cyanobacteria's ability to overcome those thermal density gradients prevents the aeration system from working as well as it could, because certain types of aeration are actually just destratification. They don't actually aerate the lake at all. They just they stimulate the spring and fall mixing conditions and try to just move the water column around enough to prevent the surface scums from forming. I really like to advocate for sediment locking treatments or water column stripping treatments, whether it be a FOSLOC or an alum treatment. We tend to, in the Northeast, move more towards FOSLOC at this point, but that's because we have really low alkalinity water quality, and alum treatments have more of an issue with pH and being stable to not run into problems with pH drops. So with that, I will close out here by talking about how the public health guidance has just gotten better over time. I really liked being able to see the progression from like the 2012 time period when I started working in this field to how many states didn't actually have guidelines at all, to fast forward when the EPA came out with their recommendations and interim guidance for public drinking water and for recreational waters. And then now you have the new updated toxic cyanobacteria in water publication from the World Health Organization. And I really think that what California is doing right now is going to guide a lot of the future statewide monitoring plans in other areas of the country. So thank you guys.
Hillary, thank you so much. We have a few minutes for questions, and if people would like to raise their hands.
I'm going to attempt to find the chat box again because that seems to have disappeared.
Yeah, and I don't think I saw anything in the chat.
Yeah, and you know, I wasn't sure how much of this you guys go over on your daily life. And are these full-time positions for the HAB, regional HAB coordinators? Like, is that what everybody here does on a full-time position for monitoring?
Marissa, you want to get
Yeah,
that?
hey there, this is Marissa. I can help answer that. So at the State Water Board, there are currently 5 full-time positions for the HAB program, and those positions were filled around June of last year. So it's recent development, though. As you probably have seen, the developments in California, guidance and whatnot, there's been staff at the water boards, many other state agencies like OEHA under CalEPA, Department of Fish and Wildlife, many other entities, US EPA, that collaborated since 2006 to develop guidance documents, and most recently with the updated statewide guidance in 2016 that we are all implementing to get recreational health advisories posted. So you heard from a lot of coordinators today. Majority of them are borrowed from other programs and don't have too much time allotted to work on the subject.
Well, you guys are doing great. I like that California posts all of their data publicly. It's really useful to people. And I'm trying to get New York and Connecticut to emulate what your program has.
Yeah. No, it's great when we can share the data. Yeah, it's a big priority at CalEPA and at the water boards to make our data as open as possible. We have an open data initiative. I don't know if you want to reference that, and some like guidelines that have been developed with many different agencies. I mean, you know, we all tend to have the same hurdles that we have to overcome and that kind of thing. So maybe that could be useful to some other states as well.
Yeah, for sure. Thank you.
Looks like we have a question from Angela Dow, and we're going to go ahead and also, Susan, if you want to pull up slides for the next presentation, that'd be great. Go ahead, Angela.
Hi, my name is Angela. I work for County Lake on Clear Lake. Great presentation. Thanks, Hillary. I saw it at NOMS too. Your guys' longer one. Thanks for being here. I have a technical question, and if it's too long, if you want to put the response in the chat, that's totally fine. I had a question kind of follow up for the sediment resting species, the overwintering. If there's any research or any generalizations for those species that are more or less co-limited or nitrogen limited. So not just driven by phosphorus, but if there's any relationships with co-limitation or nitrogen limited species that have a prevalence for overwintering in sediments and surviving to the next year. Is that something that's been studied, or you have any general information about that?
Yeah, I've read a lot of papers about nutrient co-limitation, and it makes sense in a lot of cases. And I know that lakes tend to be phosphorus dominated or phosphorus limited systems, but it's also possible that nitrogen plays a huge role in cyanobacteria blooms at the surface, because it's almost always ammonia that correlates with high cell concentrations. In terms of the benthic cyanobacteria, ammonia is constantly released from benthic environments as well. So I wouldn't see that there would be, it needs both, right? It always needs both. And I think that they switch back and forth between what's actually limited. And the whole concept of nutrient limitation is really interesting because it's nutrient limited in a space, in time. It might not be nutrient limited 10 feet in the other direction, if that makes sense.
All right, wonderful. Thank you, Hillary. I wish we had more time to ask you lots of questions. Will your slides be available after this presentation?
Yeah, I can send them to you.
Okay, after this meeting. Okay. Thank you so much. We are going to move into the drinking water and HABs portion of the agenda. So Susan, we are seeing the, yes, perfect. Okay, so go ahead, David and Isadora. Thank you so much.
David, Isadora, do you want to jump in, or do you want me to do a little context?
Yeah, sure. A little context would be good before.
Okay, great. So I'm Susan Paulukonis. I'm one of the co-PIs of the CalWATCH grant. We'll talk a little bit more about what that is. I think a lot of folks on the call have probably heard some about the amazing work that we're doing in collaboration with, really the lion's share of the work is being done by Big Valley. But up at Clear Lake, we have funding from the CDC for 5 years to focus on issues around drinking water, issues around cyanotoxin in freshwater recreational settings, and support for what we do, which is collect data on the human and animal impacts and report those up to the CDC system. So this survey that David and Isadora will be talking about is just one component of that grant. For our first year, we did a survey, did a lot of outreach to folks in the Clear Lake area, and David and Isadora will be sharing the results of that, the methodology and the results, and then Sarah and I will be talking about some of the drinking water work that we've been doing, and we're excited to be here. So take it away, Isadora.
All right. So yeah, the CalWATCH project stands for California Water Assessment of Toxins for Community Health. And one component of this, as Susan mentioned, was we were aiming for 200, but we actually got over 400 responses from residents and visitors on their use of Clear Lake. So next slide. So yeah, the purpose of the data was to collect data. The purpose of the survey was to collect data on awareness of HABs, resident and visitor behavior and experiences, and the utility and effectiveness of HAB outreach in the Clear Lake area. Next slide. And so we used a variety of methods to kind of get the word out about this survey. There were several posters in both English and Spanish with a QR code as shown here, posted around the perimeter of the lake. Sarah actually did a few local radio segments as well to get out the word. And there was also an article discussing our project in the Lake County News. And I think the vast majority of many of the surveys that we got were from promoted Facebook posts that discussed the surveys. But we actually did do some in-person outreach as well in late July when our whole team went down to Clear Lake and we distributed the survey at different popular areas around the lake. So yeah, as I said, we got 412 responses. They definitely did skew female and a little bit older. So 69% of respondents were female and 59% were 55 years old or over. But there was a really high awareness of HABs. 94% said that they were aware of HABs in Clear Lake. 64% of residents lived in Clear Lake full time. So many people had second homes or were just visiting for the day. And 44% of respondents actually reported experiencing a health issue potentially related to HABs, and 37% of respondents with pets or livestock reported them experiencing symptoms potentially related to HABs. Next slide. So we asked about what activities were most commonly conducted on the lake. The most common was kayaking, rowing, or canoeing. So almost 50% did that at least once a month in the summer or fall. Almost 50% drove a motorized boat once a month or more. 36% spent time by the lake once a month or more. 30% waded no deeper than their chest once a month or more. 28% swim once a month or more. And then finally 8% participated in tribal or cultural activities once a month or more. So again, as we said, there was a significant number of people, 44%, who had experienced a health issue potentially related to HABs. The most common one was red or itchy skin, followed by sore throat, earache, coughing or wheezing, diarrhea or vomiting, stomach, abdominal pain, skin blisters, or agitation. And the vast majority didn't contact any health professionals regarding the symptoms, and 16% visited their regular health provider, 4% just called or visited another provider, and 2% used a hotline. Fine. And so regarding pets, I think 36% of people who had pets on the lake, they experienced some symptoms. So the vast 24% of people with dogs, 24% of respondents had dogs that swim in the lake, but 50% said that they don't rinse their animals after they swim, which was interesting, and only 33% said that they do. And then we got a number of sometimes and other responses. I'll pass it off to David now.
Well, thanks, Isadora. So we also asked if folks that had pets or livestock experienced any of the following symptoms after drinking, swimming, or being near the lake water. The most responses we got were vomiting, diarrhea, and then followed by weakness, difficulty breathing, changes in behavior, drooling, foaming. I think we got 4 responses where folks said that they had seen death in their pets, and then a fraction of responses around seizure. We also asked if the animals experienced symptoms were they seen by a veterinarian. As you can see, almost 90% of responses said no. We also, of those that were seen by a vet, we also asked if they were diagnosed a problem related to HABs, and only 3 respondents said yes. Next slide. So then we asked, if you learn of a HAB, what action do you take? 77% of respondents said they'd keep children and pets away from the scum. 42% said they would avoid all water contact. 27% said they'd go to a different part of the lake than planned. And about a quarter of the respondents said they would avoid all water contact if the water looks bad only. Next slide. So then we also asked how the activities at or in the lake changed over time due to HABs. As mentioned before, respondents said they don't let their children or their pets go into the water if there's any algae. They don't take their dogs on walks, no dogs on the beach. They don't let their dogs swim in the lake. A lot of folks mentioned they would fish less, or they take more proactive measures to wash their hands and any fish that they would be catching, if they're going to eat the fish. Some folks said they'd stop eating the fish altogether. Folks said that they would no longer jet ski, boat, or kayak in the lake. Some that do boat, they would go to other areas of the lake that weren't impacted or deeper water areas. And some folks have said that they've completely moved away from Clear Lake. And some other folks have also mentioned, stop hosting reunions, get-togethers, different social activities at the lake as well. Next slide. So we also wanted to know who people found out about HABs at Clear Lake. Over 50% said that they learned about HABs through just observation. They were also notified through advisory signs that were posted around the lake, a lot of word of mouth, and then also through Big Valley's website. About a quarter said that they learned through the Lake County Agency. In terms of how notifications could be improved around HABs, a lot of folks said that they would appreciate public alerts like Knoecklein, more frequent reminders, and additional information on risks posed by HABs as well. Some folks also mentioned wanting some signs in English and Spanish. That was helpful. So then we asked about the preferred method to be notified by HABs. As Isadora mentioned, a lot of folks are on social media, and that was a really good way to get our survey out. But folks also mentioned that they would appreciate learning about HABs through social media. Getting an announcement from the county or reading a press release would also be helpful. 35% of respondents said through email. As mentioned earlier, folks are really aware of the signs that were around Clear Lake. Some folks mentioned hazard flags at Clear Lake, and then less individuals mentioned receiving text or phone alerts or getting alerted through a newspaper or website. And then in terms of languages that folks wanted to receive information about, majority said in English, just a small number in Spanish and other languages like Mandarin. And then we also asked about the number of meals that folks in the household eat. So fish, bivalves, crustaceans from the lake. And a majority of respondents said that they actually don't eat any fish, bivalves, or crustaceans. So 98% and 1% said 1 to 3 meals in a week, and then less than 1% greater than 4 meals in a week. Next slide. So in terms of next steps for our study, we're really interested in learning more about the subsistence fishing community and those who don't speak English that live around the lake. We want to do more targeted surveys to try and get responses from these individuals. And then we also want to share the results with Clear Lake agencies as well as the community. I know Susan mentioned earlier through like a series of webinars and things like that that we might be doing later on. And that's it.
Thank you. Sarah, do we have time to have questions in between? While I swap out the slides?
Yeah, there's time for a question or two if there are any. Thank you so much, David and Isadora. So are there any questions for the survey presentation? All right. So next CalWATCH presentation. Thank you so much, you guys.
Just a sec here. Right spot. Oh. Can you see that?
Yes.
Okay, I have conflicting messages on my screen, sorry. Okay, I will start and kind of go through the methodology and the funding pretty quickly, because the real heart of this presentation is in what happened and then the results, and Sarah will be taking us through that. So let's first get me moving forward. So as Isadora mentioned, we have a cool acronym, and as I mentioned earlier, this is a CDC grant that was awarded to our program, Tracking California, which is part of the Public Health Institute. And the primary collaboration here, and as I said, really the bulk of the work is being done by Big Valley, but we also are in partnership with lots of state agencies and entities, and really appreciate this sort of multi-agency collaborative approach to this work. It's been great. This is a 5-year grant. And it has lots of different components. This is just one part of it. The survey was another part of it. The aim for this component of the grant was to look at drinking water coming from self-supplied systems. So folks around Clear Lake shore who were not hooked up to the public water system. So they were either drawing water from a nearshore well or from a lake water intake. And we wanted to test their tap water and look at contaminants that might be in there. So the process was complicated and a little arduous, but we got there, and we're excited that it's going to be pretty streamlined for year 2. First, we had to figure out which properties were not on the public water system. So we did that using the Tracking California's water boundary tool and parcel information from the county, and sort of overlaid those things, and then did outreach to all those parcels on the properties that did not have a structure on them that was worth, I think in the first year we did, worth more than $10,000. So we did outreach to them by mail. We did a lot of Facebook posts. Ultimately, Big Valley went out and did door hangers on a lot of these doors to reach out to people. For the folks who were interested and got back to us, we did an informed consent process, and we did a questionnaire from them as well, learning about their water habits, how they use the water, were they drinking it, were they cooking with it, were they bathing in it, about their treatment system, about any other, who was in the household, any other information that we could get about the water use, and as well as any symptoms that they may have had, health problems that they may have had. Then Sarah and her team set up appointments to go out and collect water. They usually got a lot more information while they were out there. Actually, I left out the part where Alfred went out in a boat and tried to identify all of the intakes around the lake, which was quite a process and incredibly helpful. And then the water was collected and tested, and then information was returned back to the residents. We'll be returning more in-depth information to the 52 residents. Actually, I think we're up to 54 residents in the next couple of weeks. And a lot of the work since then has been sharing the information that we found, the results that we found with, in particular, Lake County agencies, and trying to address some of the problems that were identified. So here you can see the map. The areas in orange are the parcels that were that engaged with us. I think that's right, Sarah. That these were not the ones that were identified. These were the ones that said yes, right?
These are the ones that were eligible. And
that's right. There's too many of them. Yeah. Yeah. So these are all the eligible parcels. And then of these, I think we had about 400 of eligible. And then we had 54 who filled out the paperwork and have had their water sampled, primarily owner occupied and or second homes. And I'm sure some of them are vacation rentals as well. And I think, oh yeah, one more slide. So we started off doing in the winter and early spring, we did nitrate and coliform bacteria testing and returned those results. And then there was some limited spraying for hydrilla that happened on the lake. And the Big Valley team kept track of where that spraying was happening and where these intakes and wells were, and did some sampling of the properties that might be affected as well. But then we were going to be doing the cyanobacteria, actually we were just cyanotoxin testing that was planned for late summer or fall, which is, sort of when we think of as the peak season in that area. But things started to get pretty crazy with the cyanotoxin levels in Clear Lake in midsummer. And so we switched gears, found some emergency funding, and we did a more rapid response kind of testing in the area. And Sarah will talk about those results as well. We did find a lot of both cyanotoxin and cyanobacteria, which was a big surprise. In the 34 homes that were sampled. And then there was a larger scale effort just within a couple of weeks to try and get samples from as many homes of the 54 as possible in November. And then the State Department of Public Health lab did the testing for those kind of all at once homes. And we've returned the results back to those folks from those as well. So I'm going to turn it over to Sarah to talk through what the findings were and the next steps.
Thanks, Susan. The pictures you see on the slide are actually microscopy photos from people's tap water on Clear Lake. We, as Susan mentioned, between June and September, and I just looked at kind of a different subset of time, we tested the tap water from 36 homes and found cyanobacteria in many of them. If you go, yes, so we saw several genera, Microcystis, Gliotrichia, Camptonema, and sent all of those off for both for microcystin, and we also did qPCR for anatoxin, slinosporoopsin, and saxitoxin because of the cyanobacteria we were seeing. All those did come back no detect for the qPCR. There was no gene copies. But of the 36 homes we tested, 17 had detectable microcystin in them, with 13 of them being above the US EPA health advisory. As it says on the screen, the highest value in the tap water was 3.85 micrograms per liter. During the summer, or in August and September, we had the highest toxin levels we had in our 8 years of monitoring the lake. And the highest we saw was, as I mentioned earlier, 160,378 for microcystin in the ambient water. And again, these are for the homes that are pulling from the lake. And the nearshore well properties, or the nearshore wells, had no detective cyanotoxins in their water samples. Next slide, please. This, the reason why we decided to go into cyanotoxins and do kind of two sets was because we were seeing that the intakes in particular, even with their treatment systems, were very vulnerable for other contaminants. So a little bit of a busy slide here, but it's showing the results for the intakes with the different types of treatment that they had, because these were the questions that we asked when we were out there, and also through the questionnaire prior to us making appointments with these folks. Even though people had varying degrees of treatment, they were still vulnerable. So you can see, even in looking at percent detect for coliform, E. coli, and nitrates, that there were quite alarming levels of tap water with coliform and even E. coli. The wells had problems mostly with nitrates. The intakes did not. So when by the time summer rolled around and we were getting higher and higher toxin levels, and we knew from earlier in the year that these detects were such as they were for these systems, we realized that we needed to do cyanotoxins earlier, because the toxin levels in the ambient water were getting higher. And then you can see with the last column that even 100% of the different types of treatment had cyanotoxins detected in their finished tap water. And we were looking at it from a treatment point of view, because many people are getting their, are managing their own treatment systems, or are getting the service from local companies. And it just shows that that level of treatment is just not enough. They potentially need to be changing their filters more often, flushing more often. And, you know, it's hard to say whether they'll even be able to get these, get down to a no detective cyanotoxins with some of these systems. Yes, and I have on the slide, wells that were tested had no detectable cyanotoxins, although one well out of the 13 that we tested in the summer had detectable cyanobacteria in the tap water sample. Next slide. We also did the November testing for cyanobacteria, and that's with the CDPH lab. We did test tap water from 41 homes and found cyanobacteria in 22 samples. The ambient lake microcystin levels at that time was much lower, as you can imagine. We did also reach out to people and ask them to flush their systems. And we did but when we visited them, we also asked them questions about how they had changed their, you know, how they had upgraded their systems over the summer, or, you know, changed their filters or flushed it or whatever. So we have a lot of information from this. Despite the lower levels in the ambient lake system, as well as some of the things that people did with their systems, still 10 of the 41 had microcystin values above the 0.3, with the highest result value at 1.9 micrograms per liter. And those are microscopy photos of the tap water during the November testing. Okay, next slide, please. So here's a table of just with this November testing, just looking at cyanotoxins, and then the treatment types of organizing it by treatment. And, you know, we did get a lot of questions. Of course, we sent the results out once we got them, and we're communicating with the participants and also with some of the service providers. Those are, so it was helpful. It's very helpful to see what these different levels of treatment are doing in terms of removing cyanotoxins. Okay, next slide, please. Back to you, Susan.
That's right, I forgot I was talking again. So the Big Valley team sent out email results, really personalized for each household, explaining what we were seeing. We worked a lot with our collaborators at the water boards, at OEHA, and at the county to figure out what we should suggest to these folks in terms of the safety of their drinking water, how they should use it, how they shouldn't be using it. And so did a lot of messaging around that. That information was shared with these households, as well as a copy of the test results. I think sorry, Sarah, I'm not remembering if we're talking, yes, okay, we're talking about that. And so the individual households will also be sent some more information on what we found, digging a little bit deeper, a little bit more science background, and you can see just a screenshot of what we'll be sending them here. We've already sent them similar information for the nitrates and coliform testing. But then the wonderful thing that happened, and again, so much of this was really driven by Sarah and her team, but a lot of outreach to the county agencies, to the public water systems there. Drinking water was made available to these folks, drinking water spigots, I think from 2 of the different water systems. They opened it up to make it available to the residents. The county, I believe, had agreed to pay for that water, although I'm not sure. There ended up being a big cost. The county ended up sending out a Nixle message about this, a public health alert. That was a learning experience for all of us. We didn't know that Nixle had a cost. We didn't know how it worked. So learned a lot about that. Also a lot of information put out on lots of different social media streams, and a press release that went out to the local newspapers and media outlets as well. And then from this has kind of evolved the beginning of a conversation between the Golden State Water System and the water boards about finding funding to address this problem in the long term. Not a quick fix. This is something that's going to take years, but trying to find funding for the water system to expand their boundaries and hook these households up so that they have a safe long-term source of drinking water. And we're hoping at no cost to them other than a water bill, which they don't have now. And possibly tying into that for a short-term fix, the availability of bottled water in the interim. And Sarah, did I leave anything out? Is there anything to add there? Ongoing conversations.
No, it just has identified a lot of things. And I guess one other is that, we have a lot of vacation rentals, and it just brought up the concept of, how do you communicate with guests that are there short term? So there's just a lot of new little projects that have sort of come from this information.
Yeah. And then for year 2 of this grant, we'll be expanding our geographic area. So we'll be doing very similar work, also looking at those other contaminants that I mentioned earlier, but we'll be doing it along the creeks that feed into and flow out of Clear Lake. Some of those creekside homes have wells also, and intakes in some of the more high flowing creeks. And so we'll be doing outreach there. We'll also be open to households that we did outreach to in year 1, but who didn't respond to us, who may have heard about it. They may be on the Clear Lake shoreline area, and they may want to engage with us in year 2. And I think we'll probably be able to have funding to support that work as well. I think that's the last slide. So a couple questions in the chat, but I think we answered them. The public water systems did not have any problems during the same time. And Sarah, I don't know, maybe you can speak to why I know their intakes are in a different area, and obviously they have more sophisticated treatment systems. I'm not sure which of those is the factor. Okay. And we turn it over to Rebecca. Sarah, you're on mute, so I'm
sorry. Dave is pulling up her presentation, and we have a second set of second presentation for drinking water and HABs with Rebecca Hillwig. Dave, are you
Rebecca has co-host. I think that's her pulling it up.
Okay, thank you.
But maybe Rebecca, you want to jump in and tell us that
Sorry,
there we go.
Yeah, can you guys pull it up? I always have trouble with this on Teams. I mean on Zoom, I don't know why, but do you have it to pull up?
Yes, yeah, we should be able to do that.
Perfect.
Dave, I was gonna do it, but it looked like you jumped in. So do you wanna share?
David, are you pulling that up?
Okay, for some reason, somebody, Rebecca, Becky, I think you and I may be competing.
Yeah, I gave up.
Do you see?
I've got it ready, but if you want to do it, you're already sharing, so.
I am sharing. Are you guys seeing the correct screen?
We're seeing your desktop.
You're seeing my desktop. Okay. We're definitely getting different things going on here. All right, why don't you do it, Becky? For some reason, I cannot share screen now.
Well, I'm first of all, I want to just say I'm really impressed with all of the work that you guys were able to do, especially given COVID, because that kind of shut down a lot of what we were hoping to do in Oregon. But anyway, so very impressed. My name is Rebecca Hillwig, and I am a natural resource specialist at the Oregon Health Authority, which is under the Public Health Division in Oregon. And I am the coordinator of the Cyanobacteria Harmful Algal Bloom Program here for the state. And we're the agency that issues advisories and educates the public on cyanobacteria and cyanotoxins. Next slide, please. So just like California, OHA was awarded a 5-year grant from the CDC, but the grant was pretty limited. It was to fund a pilot project on a very rural coastal lake in Oregon that has a lot of private drinking water intakes and in-home treatment systems. So it was drinking water related, and that's why we kind of got the money. The issue, of course, was the private intake owners and lots of renters who potentially are at risk for exposure to cyanotoxins in their drinking water. There used to be the public system used to pull from this particular lake, but because they had historical blooms every year, they decided to pull their intake out and put it into a neighboring lake that had little to no cyanobacteria for whatever reason, blooms anyway. And so that kind of left these folks high and dry as far as any kind of sampling and analysis or regular monitoring that was occurring, unfortunately. So basically, the money that we were given was for education and outreach. And we pretty much figured that by improving knowledge of cyanobacteria, cyanotoxins, and all of the health effects of any type of exposure, especially ingestion from drinking water, that community members would become more knowledgeable, especially about the exposure effects. And then using that information, they could explore the different decisions and implement the solutions that would best suit themselves and their community with guidance from local government and, of course, Oregon Health Authority. Next slide. So our project goals were to engage local government owners and influencers, and of course the target audience. And the influencers are really important, as you all know, because they're the folks in the community that are heard by the people that we're trying to target. It was also to provide risk communication tools to assist with reducing blooms and, of course, community exposure from those potentially affected drinking water sources. We also had a goal of IDing the types of barriers to risk reduction. So was it knowledge? Is it money? Is it services? Kind of turns out that obviously it's those three things and a few more. Again, they don't have the services anymore because the public treatment system pulled their intake from that lake. And so some of them who live closer to and have the actual system to plug into from the adjoining lake can be on that public system, but most of the folks at Silkus Lake, which is the lake that we're dealing with, are pulling from private intakes. Another goal was to facilitate the projects and activities in the community. So the whole goal is to get the community involved so that they're taking ownership of whatever's happening in that community, and offer support and technical assistance. And we would do that. We've been doing that actually pretty heavily, and hopefully towards the end of this, we'll be able to kind of back off so that the community and the local government can sustainably keep this project and the goals going. And and again, create sustainable solutions that can be maintained without Oregon Health Authority, just limited technical assistance beyond that. And then we hope to use these lessons learned and the guidance developed for use on other lakes with similar systems. Oregon's still kind of the wild, wild west, as are a lot of Pacific Northwest states, in that there are a lot of lakes around Oregon where folks are pulling drinking water from the lake through private intakes. Next slide. Next slide. So the obstacles that we found, I mean, I think everybody probably finds similar obstacles when it comes to things like this, but these are unregulated systems with no drinking water requirements. Our drinking water folks in the program here, they're hands off. They don't want to involve themselves in any drinking water systems or intakes that are not regulated. And so because of that, and because OHA knew that there was a problem with people being potentially exposed to cyanotoxins in their drinking water, the recreation program, which is the program that I coordinate, decided to step in and fill the gap. Unfortunately, because we are recreation staff, we have less drinking water expertise in our drinking water program folks. So it makes it a little bit more cumbersome for me because I don't have that expertise, but of course, I'm sure I could reach out and they would provide any information I might need. Although they're not as knowledgeable about these types of systems as they are with public systems. So another obstacle was connecting with the affected owners. I drove around this lake. It's a huge lake. There's a lot of people who live in areas where, you know, it's hard to get to. They are, you know, very remote locations. There's no internet service. And if they have internet in some of these locations, it's very sporadic. Even cell phone service is spotty. If they have a landline, it's you know, very few people have landlines. And then even the mail service is really sporadic. So there are people who come into the post office to get their mail. There are some who get mail through, you know, delivery, but there's also a lot of people who aren't even, you know, who don't get that type of service. So getting to these affected owners is very difficult, especially with COVID when we can't get out in the field and go door to door and whatnot. Getting owners in the community to care, that's always a kind of an obstacle. Sometimes when it comes to drinking water or people's exposures, they're a little bit more apt to care about what's going on. But in this case, there are a lot of folks who are off the grid. They want to be off the grid. They are kind of the survivalist mentality where, you know, government stay out of my backyard, even local government. And so, you know, there's just a lot of folks who don't necessarily want to participate or be involved just because, you know, they want to be incognito, I guess. There are limited treatment options, which of course you all know and have talked about. Though to my knowledge, there's only 2 actual in-home treatment systems that are effective at reducing microcystin down below the 0.3 micrograms per liter, but only microcystin and no other toxins if they are present. So it's kind of a very limited treatment options. And of course, resources and infrastructure are also limiting, again, you know, the public water system does not pipe to all of these different homes. So whether they wanted to be on a public water supply or not, they often don't have that capability. And money is definitely an issue. These are really economically depressed areas, and folks, you know, it doesn't cost anything really to pull from the lake except for maintenance of the systems and whatnot. And, you know, putting them on a public water supply system, you know, for them could be economically onerous. So there's just a lot of different reasons, a lot of different obstacles. And then our grant does not provide for sampling or analysis. It doesn't provide for any kind of help with treatment options. Some of the things that you guys were talking about, it doesn't, you know, it doesn't fund those types of things. So we can kind of move money around as needed, but we need to have a good reason to do that. Next slide. So the unknowns, I kind of talked a little bit about this. Contact information for many of the owners is unknown. Even the local city government official person had, she's got about, I'd say maybe 50 to 54 email addresses. Some of those email addresses are no longer valid. The post office does have, you know, mailing information, and we did actually use that in the beginning to send out a every door mailer, just to talk about cyanobacteria and the toxins and this particular project we're working on. But it's really difficult to contact these folks. We really didn't know the type of filtration and treatment that was being used. Everybody's a little bit different. You know, we did provide a survey. I'm impressed again by the numbers of people that you got to actually answer the survey that you put out. But we had about 19 households that responded and 48 emails that had gone out. So pretty low percentage. The treatment systems and even the intakes were kind of across the board. They were just very varied in what they're using. And a lot of people, we tried to kind of nudge their contact information out of them, but I don't think we got any contact information. Pretty much, again, not wanting to provide contact just for a lot of varied reasons. And we also have the issue of vacation or long-term rentals. There are several long-term rentals, and there's also a few, you know, Airbnb, Verbo, you know, those kinds of operations in the area. And so the concern is not just for those folks who live there year-round, but also getting that information out to both the owner of the home and the person or people who are renting, or whether it's vacation or long-term, so that, you know, everyone knows about it, not just the owner of the home itself. Next. So our deliverables, again, was really based on education and outreach. So we were tasked with developing a risk communications plan, which we've done. And that basically, as you know, lays out the groundwork for all of the guidance, the education, the materials that were developed. And hopefully that is something that the community itself will be able to use going forward. With help from the local municipality. Again, this area is really, the city is like about 4 to 5 buildings. That's about it on the lake. So, so the risk communication plan was not just a plan, but it also has guidance and the education and outreach materials. And that includes fact sheets for owners, renters, vacationers, dog and livestock owners, people who are fishing in the lake, which there are a lot of because they do have a salmon population that comes up from the ocean. We developed a PowerPoint presentation template. We have a children's comic strip. We developed social media posts that the city, the community, and anybody else could use to get out on Facebook or Twitter or whatever. And we also have templates for press releases, flyers, resident letters, and some other things that we developed as part of that risk communications plan. Next. And we also, again,